Okay, should be recording those at that. Awesome, thank you very much.
I'm Chris.
Steven, Steven, John, nice to meet you.
For sending an email. Nice.
No problem.
Very helpful and critical step.
Hopefully I spam with the right information. If I can do anything else to help you or anything else, that's all.
Awesome, awesome.
Oh, some food there. Yeah, thank you.
Yeah, Clint brought us some pastries, scones. Yeah.
Yeah.
This can be.
I'll take a box.
Wow,
All right.
I didn't realize there were pastries. Yum.
If you look underneath your chair, you'll find a box of pastries.
All right, so we have a couple people in the video room already staring around. So why don't we get started in some capacity? I'm going to be looking over my shoulder a lot just to see you all. But all right, so I think that Jonathan and David Burns are not online at the moment. Jonathan had a medical situation to take care of, and Henrik as well is at a doctor's appointment. So they won't be online right now. But Andrew, do you want to say hello?
Hey.
All right, this is Andrew.
I'm here.
Some of you may know me. Andrew and I are some of the more youthful members of the A team, and we're mentors for this training. The other mentors are Henrik, Jonathan, Griffin, and David Burns. And if you want to know who to chat with, at the bottom of the Etherpad, we have the pairings for mentor-mentee situation. And so, yeah, this is a work in progress, but we're expecting that, you know, as needed, the sort of mentor-mentee relationships will continue throughout the quarter. So this is really your go-to person to ask about questions relating to this project. I would really appreciate it if we could take a minute to everybody in the room introduce themselves, because I have a lot of new faces here that I'm not familiar with. So, how do I get a list from video of who is on?
You have to go to status and then conference status. So.
Oh, excellent. Okay. Hello. Okay. Great. So I've already met everybody in who's local, but we can go through the list. Bob Silverberg.
Yes. I am Bob Silverberg, and I work on the Web QA team. I do a lot of test automation with WebDriver, so I'm fairly familiar with the concepts, and I think it probably won't be that difficult for me to pick up what's different. I did work on a couple of Mozmill tests about 2.5 years ago.
Oh, great.
As a contributor, and so I'm looking forward to finding out how this stuff works and learning stuff so that I can then maybe turn around and be able to help other people on my team or in QA.
Excellent. Okay. Dave Hunt. No reply. Okay. Matthew Brandt.
Hi, I'm Matt Brandt. I am also on the Web QA team. I do a fair amount with WebDriver and Python for test automation on our projects. Yeah, looking forward to this this training, and seeing how we can help.
Great. We just heard from Juan, but say hello.
Hi, this is Juan. I work with Liz on E10S for desktop.
Awesome. Okay. Cool. Masha?
Hey, my name is Maya, and I just joined last week. I'm part of WebQA, but focusing on platform quality, and I guess that's the story.
Great. Oh, we have some Toronto participants from the Shepherd room.
Hey, I'm Camille. I work on security with Matt, and yeah, I'm looking forward to the training.
Awesome. Awesome. And Robert Kaiser.
Yeah, hi, I'm Cairo. I'm program manager on the Firefox QA team, and I'm the one running the update tests right now for releases and doing all the release stuff for Firefox QA and stability stuff and whatever. I'm mostly listening in to know what's going on here because I will need to have the overview of things going on.
Great, great. Yeah, I hope to cover a lot of that presently with the first intro presentation. Great, thanks everybody. Good to see some faces and get to know your names. All right, so while I have everybody's attention, I think we should pretty much dive in to the first presentation. So let me start by just talking about how I think this about how I think this should go, and we'll see how far we get. So I have, if you look at the schedule Etherpad, basically what I prepared is 4 little presentations and you know, units, lessons, if you will, that will involve me talking for a little bit, then me sort of stumbling through some code live on the screen for maybe more time than just talking, and then some things for that if you're interested in, you could go off and do some exercises, some very basic stuff. And so that's sort of the formal training where we'll all be in the same area, sort of looking at the same screen. And then the rest of the time, I think, will be pretty well spent going through the test cases that we've targeted for this. And those are listed on the M21S Etherpad. There's a list of, yeah, there are 3 directories of tests that we have, that we're pretty confident we have the library support to do a pretty straightforward translation to the new framework. And there may be some, yeah, I'll talk about this later, but it won't be possible in every case to do, or even really desirable to do, like a line-by-line translation from Marionette, from Mozmill over to the Marionette-based automation. So the idea I'd like to promote is sort of reading through these test cases, running them if that's super helpful, and getting an idea of what they aim to cover. Sort of what is the specification that's being tested by this test, and then using the tools that I'm going to talk about today and tomorrow to re-express that in the new framework. So that's sort of the idea I have. If you look at the Etherpad, these are ordered. I went through these quickly last night. I've ordered each directory by sort of easiest to hardest in my very approximate assessment. This is mostly based on how long the tests are, which in my experience makes them harder to convert, frankly. So if you want to start at the top, that might be a good strategy, and work down them. And what I'd like for us to do once we sort of break off into mentor-mentee pairings and work through these things in smaller groups, is replace these links with links to an actual bug that you file and assign to yourself. And we have a tracking bug for the first set of tests that we're converting this quarter. And so if you make it block that bug and go through that from there, that should work out fine. Our development process is we're working from the Firefox UI test repo, and we're using pull requests, and we're using the GitHub UI for code review. But everything you see in GitHub, we're mirroring in Bugzilla. So if you are requesting review, you should do so with a Bugzilla attachment, but just link directly to a pull request. And there's some examples of that I'll link to later. And then the sort of feedback happens on GitHub, and then once the review is accepted or canceled or R minus or any combination thereof, we'll just mark that in Mozilla and then merge appropriately. So that's sort of the nitty-gritty of what ideally I think would happen as a result of the training. And yeah, does anybody have any questions before I start talking more? All right. Oh, let me link to the slides. So I'm going to put links to the actual slides in the schedule etherpad, and if you'd like to follow along there, that's good. The slides I'm considering not just a presentation aid, but actual documents themselves. I notice people in computer science, they like post slides as though they're standalone documents. So the slides themselves are fairly verbose. So you might benefit from looking back at them. Cool. So great. So this morning's presentation is going to be like, what is this project about? What are we doing here, and why are we doing it? And then how I think we could achieve our goals. And then I'll talk a little bit about sort of testing, an introduction to what I think automated testing is good for, with a little bit of academic standing, but mostly due to my experience just working on automation and what I think makes for good test automation. And then we'll have a segue, a little bit about Python unit tests and sort of what I think that's good to go over initially, because it's sort of the deliverable, right? Like at the end of this complete conversion of a Mozmill test from JavaScript to Python will result in something that's a unit test-based Python test. So we're going to look at a skeleton of one of those briefly, and then we'll segue into more details about Marionette, how to use that. Oh, yeah, even more meta commentary. Talking a lot already. All right. So I understand, I think some people mentioned that they sort of have a lot of experience. They've probably worked on Mozmill tests, probably know a lot more about Mozmill than I do. People have worked with WebDriver before, probably do this in their daily job. And so for a lot of people, this might be mostly review. And for other people, sort of the idea of grabbing a JavaScript file and translating into equivalent Python file and looking through all this API reference and figuring out how it relates to the browser might seem like a more challenging task. So I made a slide for each group. So if you're feeling sort of lost, this is my advice. So this is a lot of material, and we're going to move quickly. So keep that in mind. I don't expect that any one of these things, if you're seeing them for the first time, you will internalize the very first time. But if you stick with it and you sort of look at it over and over again, this is how I learn at least, one of the times if you try it, you'll actually find that it's familiar to you, and things actually do work as you expect. And it's a great thing. So if you stick with it, that's sort of the reward at the end. And so I would encourage that, and sort of understand that that might be your learning style as well, to see things multiple times before they internalize them. That's at least how I learn. This is hard stuff. It's not the frameworks the tools that we've built are really intended to be as simple and straightforward as possible, and fairly user-friendly from the standpoint of actually writing tests. The hard part comes with the browser UI, right? Like the browser, the web is becoming like an operating system in itself. Like this is one of the more complex programs on your computer, And so at any moment, you're trying to wrangle it, right? Like you're trying to figure out what it's doing and make sure it's doing the right thing. And so a lot of things can go wrong, and there are asynchronous processes to take into account. So this is actually really hard stuff. I think last quarter, when I was converting some tests as a proof of concept for this project, I gained some appreciation for how hard it is to write tests. I hadn't actually written tests before for anything other than my own code, and so I gained an appreciation for that. It's having a test that actually tests what it's supposed to test and fails when it's supposed to fail is a legitimately difficult project in my view. Great. So yeah, I've tried to make. We have a lot of documentation compared to other Mozilla projects. So read everything. Read the API reference. And read them again. That might be a good help. And there's no replacement at the end of the day for reading the code. If something is not making sense, and you really need to know what's happening, read the source. That's another thing that I think really is true. Trying to work with this, and then also ask your mentors for help. They've agreed to help us out, and so ask them, ping them on IRC. Most of us hang out in Pound 18, if not Pound Automation, on a daily basis, and we'll go from there. So this is for the other group who finds this mostly review. If you want to catch up on bug mail, I won't take it personally. I think that's better than feeling like your time is not extremely well spent. So the other thing is if you really do have experience with this, there's a lot of things beyond what we've targeted for this training that I think will be useful and very difficult as we're pushing this to completion. There are a lot of libraries, there are a lot of tests to convert, and so if you find yourself in a position to invest in different areas, definitely reach out to. I think Henrik Wimbo in IRC. I think he's probably the best person to talk about. He has really the depth of knowledge about the existing tests and libraries, but I can definitely point you in some more directions. The other thing is that these tools, Marionette, the libraries we've built, they're potentially applicable outside of Mozmill and E10S, right? So we have this project, but really what we've built is a general browser UI automation framework, and it's one that will work once E10S ships. So you can think of this as an opportunity to evaluate these tools for your purposes, for whatever it is that you're working on. So yeah. And then just some general comments. All of this is in active development. Henrik merged some of the libraries we're going to work with while I was sleeping this morning. So, all of this, if you see something, say something, right? Like, if something seems like it's really going wrong, I'd appreciate it if you reach out to me or file a bug or talk to your mentor. At least for me, this project is really the focus for me for this quarter. So I plan to be as responsive as possible with any issues that come up. Great. I think I covered that last point already. Okay, so what the heck is Mozmill? So I see Mozmill as the Firefox browser UI automation tools and test libraries. So everything up here, right? Everything I can click on, everything I can interact with, that's, making sure that works. The thing that's interesting about Mozmill is it supports a lot of things that we don't do on TreeHerder and TBPL. It supports some things that we don't allow in Moki tests or XPC shell tests or Marionette tests as they exist there. And among those, this is not a complete list. Among those are we hit the network. That's important. We run tests invoking multiple binaries. So update tests are run with Mozmill. We don't have, TreeHerder has this idea of a push. That's a change set in Mozilla Central. That's a build, and then we test the build, and those are the test jobs, right? There's not not really an idea of multiple binaries. But I do know that these are this is an important area for our test coverage. The other thing about Mozmill is that we test localized builds with Mozmill, and that's something we also don't do in mainline CI. So a Mozmill test is just a JavaScript program, and they run in an environment that's an add-on that runs alongside the browser code, and then it communicates with the automation framework over something called JS Bridge, which is also an add-on, I believe. So what this means, the instrumentation code in the add-on means that we don't run these on B2G. B2G has no idea what an add-on is. There's no add-on system with B2G at the moment, so we couldn't go there with the approach. And it also means that because the tests themselves run as JavaScript alongside the browser, they have unfettered access to the browser internals. And so inevitably, this means some coupling with the browser implementation. As the browser changes, the tests have to change. And that's sort of why we're all here, and I'll talk about that in a second. All right, so yeah, there are a lot of tests. I think the estimate is we have 500, 600 test cases. This is an important corpus of test coverage. It's got years of work behind it. I linked here. These links are also in the Etherpad. Yeah, and here's just a taste of Mozmill code. I thought this was a good little snippet. It shows you. So this is JavaScript in a specific style. You see these things: expect, tabs, assert. These are all libraries that are controller, utils. These are all libraries that are provided by Mozmill. So there's a high level of abstraction, right? Like the basic unit you work with is something called tabs. It's something that like a user understands. And so, yeah, that's sort of the quality of Mozmill tests. The other thing I wanted to highlight with this is these tests are pretty well documented and commented, right? So, we have a comment here. These are assertions that have strings associated with them, right? Like this is the specification. The specified search engine is installed. So this is something that I think you can lean on when you're going through test cases. That two things. It has the libraries are fairly declarative. They work with concepts that are facing the user, and then they're pretty well documented. So that's I think will be helpful at this point. And this is something we'll see later. This wait for function. Come up. Oh, it does come up. Yeah, and so this is an anonymous function that when it returns true, it completes and moves on, and if it never does, after a timeout, it will fail the test. And we'll see an analog of this later on today in Marionette. And this is a pretty important concept that I want to bring through. All right, so what's electrolysis? Run web content in a separate process. That's the sort of shortest explanation I could come up with. So I have another slide for this, but everything you see down here, below the URL bar, that's sort of web content. Everything above is Chrome, the browser UI. And those are separate processes in electrolysis. They aren't today. So why would we do this? We have a couple of considerations. Performance is important. Stability and security are important. And so the most compelling story that I've heard about why we're doing electrolysis is that you have your web content, right? And if it's running in the same process as the browser UI, bad, slow, janky web content can freeze your UI, right? And so that's like, to me, that's really unacceptable from a user standpoint. Like, I went to this page, it doesn't want my computer to work anymore, it doesn't want my browser to work anymore, and it has that power. And so I think that's like the most compelling story I've heard for electrolysis that I can relate to as a user. And then the other thing is Google Chrome. When Google Chrome was released, they had this. Many of you've probably seen this. There's a comic talking about that was produced by some Google employees, I think, that talking about everything that's great about Google Chrome and better than every other browser. And one of the things that they basically said was Google Chrome can't crash because we have process separation. So like that's a that's a big idea. I would want that in my browser. So, as you know, Google Chrome has been around for a few years. So this has been a project. Electrolysis has been a project since 2009. But it was recently rebooted. Maybe a year and a half ago, people started to look at this again and think about what it would take to get it landed. And so it's been a focus, I think, in the last couple of quarters. And we're expecting, at the moment, the expectation is that Firefox release will have process isolation by the end of this year, which means that we'll have merges to Aurora in the spring, in the coming months. So this is, I think it's a little bit late of where it was expected to be, but it's coming up. So, yeah. So as I understand it, the reason this was rebooted and sort of put on hold and then rebooted is compatibility with add-ons, right? So like one of the important things about Firefox is that we have an active add-on community. We have people who are, allowing people to extend the browser in almost unfettered ways is one of the things that's really cool about Firefox. So breaking add-ons is a big problem. And add-ons, because they have access to all of these things, they do things that aren't friendly to content process separation. And you might have made the connection already. Mozmill is an add-on, and it interacts with content interactions directly. These are just some terms that are important to working with electrolysis. Content versus Chrome, that's that division, and it corresponds to the parent versus child process. These are reversed. Chrome is the parent process, right? And then the message manager is the platform primitive that allows us to talk between the processes in JavaScript. We won't be working with that too directly, but I think these terms are thrown around a lot. It's important to know a little bit. And then a frame script is our proxy in the content process. It's a script that gets loaded in the content process, and then it talks through a message manager to the parent process, and that's the basic idea instead of direct access. And then another thing is a CPOW. I'm told that you're supposed to pronounce the CPOW is the thing that lets us not break add-ons, right? So this is the shim that lets us pretend we're in the same process, but that the platform provided for us that proxies over to a different process, but lets us access things in the content process as though we were in the same process. And so we use these a little bit in Marionette. Add-ons make heavy use of them, and the idea is that for the most common uses, if you have an add-on that would have broken with electrolysis, if you turn on these cross-process object wrappers, you have a chance. You have a fighting chance of having an add-on that still works. So that was one of the big innovations that I think helped to reboot the project. So yeah, this is it. This works pretty well as a metaphor for what the Chrome and content is. These are the different areas. And this will correspond closely to what we do with Marionette. Marionette has two contexts you can do work, Chrome and content context. And so we're mostly working up here when it comes to thinking about Mozmill tests. We're working up in the browser Chrome. All right. So yeah. Any questions or comments before I dive forward?
I've heard them call it kapows all the time. Kapow.
Kapow. Okay. All right. I might have inaccurate information on that. Yeah. David Burns mentioned it's sort of like the 70s Batman thing, where they have it come onto the screen. Kapow. Right. Like. So what is Marionette? So the motivation behind Marionette is to run tests without an add-on. That's like the, as I understand it, the driving force for Marionette. So we have B2G, which has no idea what an add-on is, and we need to instrument the B code. So we need something other than the usual model of having an add-on. So we have Marionette. So Marionette does something different from Mozmill. It has a client-server architecture. right? And this has a lot in common with the way it's really based on what WebDriver and Selenium are doing. So the two parts are the server and the client. So the server is, it's funny, it's a little bit reversed from what you think of how a browser interacts with a web page, right? So like the browser is the client, and it goes over to the server and requests a page. Our model is a little different. Our model is the browser as a server. So the server is JavaScript, a handful of JavaScript files that are shipped in Gecko. They're prefed off by default, but all our builds, our automation turns all that stuff on, and it listens for requests from the client, right? And then it does what you expect. It does what you asked it, and then it returns a response. It does have that quality, and actually the Selenium-based automation does this with an HTTP server, so it pretty faithfully does what the server and client you'd expect it to do. Great, and then the client is where we'll do most of our work, right? So like our test scripts, our Python files, those are in the client. They talk to the client to get to the browser, and they make requests. So there are currently two client implementations. One of them is in Python, and it lives in Mozilla Central, and that's the one that we're going to be using. And the other one is a Node-based JavaScript library. It's used for some of the BTG tests, I believe. But our automation is based on the Python client. And yeah, so it's one of the things that's powerful about this division is that really in principle, any program that knows this protocol could talk to Gecko and instrument it in order to run tests. So we're in the process of writing a proxy that actually allows all the Selenium programs to talk directly to Marionette. It's a pretty big project, but that's where something that this allows, which is exciting to me. Okay, so I gave a little excerpt of Mozmill code before. This is sort of what Marionette code looks like. This is a test that's in the tree. So yeah, this is Python. It's a little different. So this is a different set of primitives we're working with. Notice here, find element, right? So this is an element. This is a reflection closely of what the DOM in the browser is. Or in the DOM and web content is. This is not always something that a user interacts with. And we're interacting directly with the markup, right? So this corresponds to HTML somewhere with an ID attribute that says create div button, right? This directly corresponds to web content. There is sort of another layer of abstraction in the Mozmill case, but this has more unfettered access. And you see another thing here. Assert true. I actually don't know what this test must be doing. Maybe that's a bug. Okay, so this is some of the primitives from the unit test library we'll be working with. These assertion functions, right? Take two things and figure out whether they're equal. If they're not equal, fail the test. You know, this is this thing. If it evaluates to true, we're okay. Otherwise, fail the test. This is a good one that I'm going to talk about tomorrow. This is sort of one of the heavier weight things that unit test library lets us do. So it says assert raises. So sometimes things need to fail. They need to fail in a very specific way. So, and this is helpful really for testing Marionette. For this first argument, we have an exception type. This is one of the exceptions that corresponds to a problem in the protocol, an error that's returned by the server. And then the second argument, this is a funny API, but the second argument is a callable. So this is a function. So you can see this from above. This would be usually this find element. This would be usually called with arguments. It's called with no arguments here. But the arguments are given as the rest of the arguments to assert raises. So this is a little strange, but it's saying when you call self.marionette.findElement with the following arguments, this exception should be raised. If it's not raised, fail the test. It is. And so, yeah, it's not necessarily something that we're going to use right off the bat, but it's one of the quirks of the library. Oh, and the other cool thing here is this is an element, right? So the return from find element is a proxy to something that happens in an actual element in the browser, and there are methods on that that allow you to interact with it. So the two cool things that you can do with an element is you can click it and you can send keys to it, right? So like we're going to see later at the URL bar, you can send keys and have a program that types in things the user would type in, and then hit enter and goes to a URL. So those are the main interactions we have. Okay, so why are we doing this? So as I mentioned, these Mozmill tests, they are coverage that we don't have anywhere else. They catch important bugs. I think that, yeah, I think that sort of speaks for itself. And not only do they, yeah, so E10S is interesting because it's really a fundamental change. This is a big architectural refactoring. It's really fundamental, and it introduces a lot of interesting bugs, or potentially, or it has already, and it will in the future. Like, if you've used Nightly recently and had E10S turned on, you might notice interesting things like Gmail redirecting infinitely, or session restore being wonky, or all your tabs crashing. These things are lots of potential for us to catch the edge cases, right? So like, I know that Gmail redirects infinitely. There are probably a lot of edge cases with session restore that are not working quite properly with E10S. And a lot of things hidden in the corners of the Mozmill test repo that are going to be flushed out by those tests and maybe not by a Nightly user who is going to follow the right kind of bug. So that's my that's my idea. So yeah, the other thing, the reason that we're talking about Marionette and not Mozmill is that E10S is pretty fundamentally unfriendly to Mozmill. We did an evaluation in the fall, and it would be a significant rewrite of Mozmill to get it to work with E10S. So we took the tactic of moving to Marionette because it was already is set up for this. It has this separation between content and Chrome. It has all these ideas in mind. It was sort of, it came after the idea of E10S was live, so it has those ideas in mind. Yeah, and it's also, yeah, it gives us Marionette-based automation in general for E10S turned on, right? So we have Marionette in shape to automate the browser UI. We get that for free. It dovetails nicely with that. So this is my own idea of why this project needs to happen and why I think it's interesting. Is that E10S is a couple years overdue in some sense, and we need to ship it without a lot of user-facing regressions, right? The process isolation is something that is slightly difficult, I think, to justify to a user. It's not user-facing in the sense that some features are, but it has the potential for a lot of user-facing regressions. So that's sort of the eventuality we need to forestall. Yeah. All right, so the top-level goals for the M21S project that we've been working on for a few months now is to enhance Marionette with the features necessary to cover all the things that we cover with Mozmill tests. There were some missing features there that we've some of which also correspond to being compatible with WebDrivers. So it's been good to share efforts there, and then build out the libraries and infrastructure to make the conversion more straightforward. And that's really what the Firefox UI test repository is about, and particularly the Firefox Puppeteer and Firefox UI harness subdirectories. We have a harness and we have a set of testing libraries that will be useful for these tests. Yeah, so that's the top level goals for the project. For this week, what I think we might get, for this week and ensuing weeks, if this gains traction. So yeah, gain expertise with this stuff. If something you haven't seen before, that would be exciting to me. That might be good. Convert actual test cases. We're ready for help. So we have this list of test cases that we can go through, and I don't think yeah, I don't think it would be totally out of scope to have a couple of test cases up for review by the end of the week, and tomorrow even. Yeah, and then if these are things that would seem useful to other aspects of your daily life, you know, that this is knowledge that I hope you could apply there. Okay, so yeah, I talked about this earlier a little bit. Yeah, this is my idea of how we might go about this, which would be to grab a link off the Etherpad, read through a test, see what it might be doing. It might be helpful to actually run the tests so you get an idea of what they're doing, and yeah, that's something we could help you with as well. I think Mozmill's pretty straightforward to get booted up. I haven't done it in a few months, but yeah, and then like I said before, it would be my idea to figure out what a test is doing as in terms of the spec that it's testing, right? Like, what is this test doing that a user cares about? What are the steps that a user would go through that would expressed by this test? And then sort of even write down somewhere, like right in the bug summary, this is a test that opens a new tab, navigates to a URL, it does things that, you know, a user would do, and then it expects this result. If it doesn't have this result, it's got to fail. And that might be a good step so that we, yeah. I mean, I think if we go from test to specification and back to test, I think that we have a much better chance of ending up with a test that tests something we care about, right? So it may be that you get to the second step and you say, this specification isn't interesting, right? Like, this is a good opportunity to say, this Mozmill test is valuable, or this one is not a priority right now. And then you end up, yeah. And I think that's better than sort of, if we consider this line by line, taking JavaScript and converting it to Python, I think that, from my perspective, I've actually converted some tests taking just that exact approach. And I think it's easier to get off track. It's easier to end up with something that isn't built to that specification. So that's all right. How are we doing? Oh, we're doing good. All right. Okay, so this is from basic primitives of what the heck an automated test is, right? Or any test, actually. So we have inputs for the browser, which is our system. We have outputs from the browser. And then we have assertions about the outputs, right? Like, given a set of inputs, we expect the following outputs. If they don't agree with our expectation, the test fails. We back out the change set. We block the release. We say this feature is not good. And sort of the thing that tells us whether that gives us the expectations that thing is called an oracle, right? That's the thing that says, given these outputs, is this a test failure? And so in our case, we're lucky because these are correctness tests, right? So it's pretty straightforward. Like we sort of, the features we get, it's sort of known what the outputs are, right? Like you click the new tab button and a new tab opens, or you hit enter and go to the URL, or this thing doesn't crash. That's a good output, right? Like a lot of tests, we have a whole set of tests called crash tests that just run some code, and if the browser loads and doesn't crash, then the test passes, right? It's the property that you should be able to do all this stuff without the browser crashing. So yeah, our oracles are pretty straightforward. That's not the case for some other kinds of properties, right? Like if you had a function that computes square roots, the test oracle for that is kind of hard because you have to compute square roots. For any old input, you have to know what the square root of that is, and so you need like a reference implementation of the square root function. That's sort of how I would do that. Another one that's not so easy to come about is security, right? Like you have, the property there is extremely abstract, right? Like I should be able to use this browser without a virus taking over my computer. Like that's a very complicated thing to try to get a handle on. So a good test is a test that fails 100% of the time when a defect is present and passes 100% of the time when the defect is absent, right? And it's deterministic, right? Like we we want to be able to, given any iteration of the browser, run a test against it and get a result and have that be a trustable result. So in practice, this is not so easy. The environments, the product are very complicated and themselves require testing. They themselves sometimes have bugs. So yeah, that's just something. Random oranges on TVPL or tree herder are largely results of non-deterministic code in the browser or in our tests, right? So if the browser sometimes fails under certain situations, the test will only sometimes fail, right? So like that's not a perfect test, which is unfortunate, but it's a side effect of the hugely complex browser that we're testing. Okay, so I just mentioned inputs and outputs. And these are some ways that you can deliver inputs, right? So in our test cases, this will actually be self.marionette, but you can think of anytime you see Marionette, like you'll have one. We take pains to give one to you. Marionette is the brain of one of our unit tests, right? So like that's the central. If you need to do something, you go through Marionette almost all of the time, and anything else that you work with will almost certainly be just a wrapper around Marionette. And then the other part will be computing on some outputs. So you can navigate to a URL. You can go back. You can go forward. And then the other main primitive we have is elements. We saw those before, and the cool things you can do with those is, it's not that complicated, right? We have two input devices, basically on desktop. We have a pointer device, and we have a keyboard, right? So we have, we can simulate this. We can click on an element, because that's the main unit that we want to work with, and then we can send keys over the keyboard. And they're constants for the special keys, right? Like I can't type an enter key in source code without pressing enter, right? So we have these constants in the keys libraries that are, yeah, let's actually look at that. So this is the API, yeah, this is okay. So yeah, this is the reference documentation for the testing libraries that we've written. Drop a note about this in the IRC channel. I'll create these things. Okay. Yeah, this is the keys library. Yeah, read the docs is a pretty cool thing. It takes the comments in source code and creates pretty HTML out of those, which is awesome. And then it also reads through, it actually parses the Python code and tells us that this class called keys in this package has all these members, right? So that's pretty cool. And these are the constants. So if you see, where's our enter key? Right. So this enter key corresponds to and send keys takes any number of arguments. So there are a couple different ways you could write this, but you can just concatenate these constants together. You can see they're just a Unicode escape sequence here. Corresponds to special things that we reparse in the server. Okay. So yeah, again, these were all inputs. Do some navigation. Click. Type on the keyboard. Go forward and backwards. And these are outputs, right? And these are the things that you'll be asserting about. So anytime we have an element, you can get attributes out of the element. So this could be ID, right? So if we were, so if we were back here, this element, if this is working as I expected, you would then be able to say assert equal button.get attribute ID, create div button, right? So like this, that reflects the markup, reflects the attributes just directly in the DOM. So, and then we have the assertion libraries, and this is so you start with. So yeah, this is almost chronological, right? Like you start with inputs, you get some outputs, and then you make assertions about them, right? So after navigating, you can assert that you're at the URL you expected. You can assert that your element has the attribute you expected. It's in this case, this is nice. I didn't actually know this. The UI Azul markup gets annotated with special things, like the selected attribute gets put on the markup itself when you have a tab selected, which is pretty helpful for our purposes, at least, for those things. Like the focus is an attribute, right? Like you can tell when something's focused based on just the markup, which is really helpful. Yeah, and this is another instance of assert mazes. So if we try to find this element, it should yeah. Given this element is not in the document, this should raise an exception.
Stupid question for you.
Oh yeah.
No such element exception. Is element the word in there? Should that be capitalized?
Oh,
Intercaps?
absolutely. That is a typo.
I noticed the systems between things like exceptions and your class libraries that you've got things like underscores, you've got intercaps.
Yeah.
In some cases, you've got all lowercase.
Yep.
So I'm trying to understand your system.
Sure. Yeah, you'll see this is from the actual source in Mozilla Central. You're right. That's a typo I wrote.
Sorry.
No, thank you for catching that. That's good. Yeah. So this is actually, it's a convention from Python, right? So functions and methods like getAttribute are with underscores. Except for the ones from the unit test library because they're older. Right? And then anything that's a class is this camel case. And we followed this pretty closely. So this is actually a class name, so it's upcase. And if you look in here, all the methods are with underscores, and then the class name is separate. Yeah, that's a Python. Yep, sure.
Location bar. One down.
Mm-hmm.
No underscore. No, it's 2 words. Just a.
That's a quirk.
Okay.
Yeah. Yep. No, that's a quirk. Yeah. Yeah. There's a. Sorry. No, I like that. So I actually have an answer for that. There's a convention in C libraries to use functions that are lowercase and all mashed together, and sometimes they take out random vowels, right? So I think I wrote this, and I think that's why I did that. And I sometimes do that in Python, and I sometimes get corrected by reviewers to add the underscore.
Thank you.
No problem. Oh, all right. This is my test for the day. So for this morning. So this is a pretty minimal unit test case that has the skeleton of what happens. And so what I'm going to do is totally live plug this into our framework and run it and hope it passes. I might call this test feature. Hi. Oh, I already. Okay, I already did this. All right, here it is. So this is our very minimal test case, right? So the basic anatomy is the license header here. You have your imports here, and so this is ubiquitous. This is like at the top of every single test case we have. Is we need the test case class that will subclass to make our thing, and that gives us a lot of things actually. It gives us the setup and teardown. It gives us the assertion methods from the unit test library. It gives us a Marionette, which we'll make heavy use of, and it gives us access to all of our libraries. So this is really pretty cool. So, all right, there are 2 kinds of things in this. There are 2 kinds of methods in this this class. There are methods that we are running as tests, and there are methods that are part of how the tests run, right? So setup and teardown, with those camel case names, are about how the tests are run, and then these, starting with test underscore, are actual tests, right? So assertions go in here, these are run, and they need to pass or fail based on outputs. So yeah, and this is just setup and teardown are pretty much a convenience, right? So setup is a bit of code that runs before each of these. Teardown is a bit of code that runs after each of these, right? So I could write a totally equivalent test by just taking the body of setup and putting it at the top of each of these two functions, and then taking the body of teardown and putting it at the bottom, right? And so and so it's my assertion that this test passes because we have a member of the class called foo that has a value, and so this runs. We increment it; it has a new value, right? Now the next time we see it, it's reset based on setup, right? So both of these. So my position is that both of these tests pass because setup sets the class member to 123 both times. Even though we've changed it in here, and we've changed it again in here, it doesn't matter what order these run in because I have setup that runs between each one. And it is a funny feature of the unit test library that these test methods are run in alphabetic order. Not any specific order to the way you wrote them. They're run in alphabetical order. So you can't, each one really does need to be independent in that sense, right? Like you don't want to be thinking about how you wrote methods in terms of, and then think about how to reorder them alphabetically so it has the effect you want. They really ought to be isolated. So yeah, let's run this thing and hope it passes. So yeah, this is my Firefox UI test directory. Pretty much the command, the console script that you can run is called Firefox UI test. It needs, oh yeah, that's pretty good. It needs a binary. We aren't using these other options. We're not running tests through the emulator. You might have an opportunity to pass a different address, but that comes later. So we need a binary, right? And so by default, this will run all the tests that I have. And I just did this earlier. There are 45 of them. But let's run, what did I call ours? Test feature? Yeah, run our test. And then the next argument, so this is an option, -b corresponds to this, which is my nightly I vote. And then after that, with no flag, is one of two things. It's a file to run. In our case, that's what we're about to do. And or it's a manifest, which has just a list of tests in a particular directory that will all be run as a result. So let's test our feature. So as you can see, so this didn't touch the browser, right? But the Firefox test case launched a browser for us anyhow. So we got a browser, we compared 123 to itself, and then we shut down the browser. We have our results. And you can see here, this is chronological. We got test another thing because it was alphabetically before test one thing. And then this did pass. Let's see, if I set, so what's a way I can make this fail? I can make this fail in two kinds of places. I can make this fail in the setup by giving the wrong environment for the test to run in, or I can make it fail at any of the assertion functions, or I can make it fail in this mutation here. So if I started somewhere wrong, right, it would tell me, no, this isn't the environment I expected. This is the wrong number altogether. And it made both the tests fail. So that's good. And this is a good step. I've seen this somewhere else. This isn't my idea, but I think that tests are good if they fail, right, when the bug is present, right? So if I'll often find myself, I've written sort of like 60 or 100 lines of code, right? And I've written some tests for it, and those tests are pretty complicated. I want to see that test fail before I have any idea of whether that thing's testing what I thought it was. So yeah, because if the test doesn't fail, sort of the worst experience is when your test is somehow not giving the coverage you expected, because tests give people, I mean, yeah, you probably know this, but you know, tests give people confidence, right? Like this, if this has coverage, it has coverage, and it means the bug is absent, right? Like the ideal case is sort of an expectation a lot of times. Like the bug is absent if the test passes. So let's make it fail. Just make it fail. All right. Yeah, absolutely.
Okay, so for every test you have here, you're going to be, it implicitly calls the setup function. It also calls the teardown as well?
That's right. That's right.
Okay.
Yep. And this is, so this teardown, you probably noticed, is not actually doing anything, right? I'm just demonstrating, this is sort of demonstrating that the setup runs.
Right.
So one other thing I could do is I could get confused about which runs which time, and I can actually do my setup in my teardown, right? And I believe this will fail. Nope, that'll actually fail both the tests. But you can see where I'm going with that. The teardown is interesting, right? Because you mostly want to think about setup, because you don't want to change a lot. In common cases, you won't change a lot of things during your test that need to be cleaned up. Our case, there are some things. And so we actually have a teardown method that's defined on Firefox test case that does a couple different things. And one of the important ones is preferences. Preferences are this global browser state that we commutate as part of some of our tests. And so at the end of teardown, it takes the set of preferences that were existed in setup and it restores those, right? And so that's something that you can't do. I guess equivalently you could do that in setup, but it would be in no-op the first time you run it.
I was just curious. There's lots of similar test frameworks out there that do the same thing.
Oh yeah.
And it's good practice in your teardown to sort of undo all the things that you did during your test.
Exactly.
And the reason I was sort of caught my eye was I noticed that you set the self.foo value back to none.
Mm-hmm.
And I was wondering if that was just because you wanted to demonstrate to the group that for good practice you're undoing the things that you set up.
Yeah.
Or if there was also a component that had to do with things like garbage collection.
Oh no, yeah, memory. The foo member would be killed with the class instance.
Okay.
So yeah, it's not a memory management thing. Yeah, it's mostly that. So yeah, that's right. If we had, if somebody else was trying to interact with us and looking whether we had a foo, we wouldn't want to have one around as a result of the tests, right?
Good practice.
So yeah, it's a good practice. It also demonstrates that foo is set every time in setup, right? So if it wasn't, if it wasn't run every time, some of these would fail because foo might be done. Cool. All right, so yeah, I wanted to go over this early because this is sort of the, like I said, the deliverable, right? Like this is the end product is one of these Python files where you can do this and it turns green. Yeah. Cool. Any questions about this before I go back to slides? Cool. Yeah, I have a feeling this might be more like review. So that's okay. And then the last thing I have for this morning, for the moment, is this preliminary exercise that I came up with. And there are instructions in the Etherpad for getting these here. I have them on my own branch called examples, which I'll be updating over the course of the next few days. And this is pretty much a repeat from, I think I pushed this up for Portland, but some of it's updated for the new, I updated it to run with the new name. And this is a good thing to work through if you're not quite feeling ready to dive into an actual test case. They're pretty simple. I think this is the best place to start. This back forward is a good one. And then we can move on to opening a tab, and then this interacts with preferences. Yeah. So there's the straightforward approach, which is write a test that passes. My sort of exercise is to write a test that fails. And then once you have a test that fails, you can do the straightforward thing, which is change the test to make it pass, or you can change the browser state to make your failing assertion true. That's my challenge if you're interested in that. Hey, all right, good. So that's the end of this morning's presentation. That's it I have for now. That took about as long as I expected, which is. And so, yeah, at this point, feel free to, like we can start the discussion with mentors if they're around. We can go through actual tests. Like I said, so Etherpad has this good quality of concurrent edits, right? So as we're claiming tests, let's get Etherpad up to date, so we don't have any duplicated work. And yeah, we'll break for lunch in about an hour, and then we'll come back as a group for 1 p.m. and we'll talk. I'll spend a lot more time going through the actual Marionette functions, how to use those, and some examples for that. Great. Any questions before we break? Oh, yeah. Yes. So the question was from Rebecca whether, because David isn't online at the moment, whether she can work with me, and that's great. Yeah. If you guys need questions, like I'm here. I'm here. If your mentor isn't, so there you go. We have another question from online.
Yeah, sorry, I was just looking at the instructions, and unless I somehow got the wrong repo, I don't see an examples folder under Firefox Puppeteer/tests.
Okay. Yeah, this is on my. Are you on Mozilla/Firefox US, Firefox UI tests, or CHN
I brought
tests?
down your branch.
Uh-huh.
I cloned the repo, and then I brought down your examples branch.
Huh.
Do you have, Bob, do you have, it's the other Etherpad M21S? It's got a link to the Mozilla repo.
Yeah.
Let's see. No, I think it's here.
Yeah, I don't. So why am I not seeing it? That's very strange. I just
Did you
pulled
check
your
out
branch down. Yeah, I did. Like.
Yeah.
Anyways, I'll do it again.
Okay. Yeah. It's all here. If you just want to copy paste in from here, that's what I would do. If I was having trouble with Git. So. Yeah. Okay. Great. So I guess we can all hang out in the video room. And I'll be on IRC as well, Pound Automation. Don't need to disconnect, but we can probably mute. And we'll come back together in a few hours. Oh, I'll probably stop sharing my screen. That's good.
Chris, I might virtually sit with you and Rebecca.
Yeah, sure.
David is also my mentor.
Oh, all right. No problem. Yeah, I'm not sure. I know that Jonathan, you might try. Jonathan. Yeah. Yeah. Clint is. Yeah.
Or should I? starting with that branch there.
Yeah, if that seems like a useful thing, we can go there, or by all means go to Mozmill. Yeah. Okay. Okay.
So we had Chris's example. Balancing technology.
Full origin. And then just putting the add of the remote doesn't actually.
I get only eat so much, Clint. Stop feeding us.
Try harder, Matt. You can do it.
Yeah, they're like cute. No, they're not like your delicate scone sorts of things. They're like.
I wonder if has anybody else successfully pulled the examples branch?
I tried.
Yeah, the issue was, I think someone already tried to tell me that. The issue was in the Etherpad, it's pointing at the Mozilla repo. I think maybe you updated it.
Okay.
Where it says, git remote add.
Yeah, I've updated it.
Okay, it used to say the Mozilla repo
Yes.
instead of your repo,
Oh,
so
okay.
I was pulling from the
Yeah.
Mozilla repo, and I fixed
All
it.
right, that totally makes sense. Oh, okay. I wonder if that's. Yeah. That's that's all right. We'll start. If you already did that, you can use git remote set URL, which will set the remote back to a different URL, or just use a different remote. My apologies. We had a good question from Rebecca. She was saying that from working on WebQA, the Marionette stuff seems pretty familiar, but the Mozmill stuff seems pretty foreign. So her question was whether it would be worthwhile to really to try to get Mozmill up and running and set up locally. My feeling about that is that if you can understand the Mozmill test and what it's testing, you're 100% of the way there. So if you can read it and infer or assert what it's testing and write an equivalent test, that's totally good enough. But if you really think that running the tests locally would be a prerequisite to that, then it might be take some time. So I think that in the next few minutes I'll try getting Mozmill up and running and see if I can come up with some instructions for that. I think it's straightforward, but it might have some sharp edges. Oh, it's in the repo is Firefox UI test. Yeah. Oh, yeah. I think there is a repo called Firefox Puppeteer. That's out of date. That's totally out of date. All right. Okay. That's totally right. That's totally right. Possibly. Yeah, that's no good. So this makes me think. Do you have a GitHub account with a key register on GitHub? This totally shouldn't.
I have to pick up a count.
Yeah, this totally shouldn't be necessary. Yeah. Maybe they'll let you get it over HTTP. Yeah, there you are. Yeah. I don't know. It has something to do with SSH keys. I don't understand. Yeah, that should be good.
Yeah, well, work around.
Just say something. I need to update it. So the steps in yellow, alternative. This is our path, right? So this is if you want to run something out, check. There is a version. It's downloaded.
I already added the repo.
Yeah. So all you have to I had another question that pointed out something I should have mentioned, and we'll update. On the on the README for Firefox UI test, the first thing it says is to use pip to install the library. Our path is this path. Below that, to use GitHub and Python set up that pipe. So ignore this completely and take these steps instead. I will update that post-haste. Yeah, if that sounds like something useful to do, I think that, yeah.
Those are just examples of tutorials.
Yeah, so that's sort of the contrived. Those are things I thought like, oh, this is a basic thing that we can do. Like if you want an example of something that's relatively easy, you can do that. If you're ready to dive into Mozmill tests, that is, that's why we're all here. So like, by all means, go for that. I think, yeah, it's a steeper learning curve because it's, the spec isn't written out. No, it's just a JavaScript test, right? So you have to decipher figure out what it's doing to go through there. But
Bigger question I guess I'm asking is what would you like us to do now? Because I see a bunch of things not over here, and obviously the ones you need with local repo are working. Was your branch something just to help us?
Yeah, that's right. That's right.
Okay.
Yeah. That's an optional. Yeah, that's a totally optional step at this point. Yeah.
That's for people that would like to see those locals.
Yeah. If you want something to help you get familiar with it, that's my offering for something to dive into. but not a prerequisite to the project, to the core of the project at all.
So then the next step after that, we start finding tests that we might want to.
Yeah.
Okay.
So to through these, and honestly, I think that the awesome bar test makes more sense to me, frankly. So that might be a good place to start.
Okay.
Yeah.
And if we'd like to claim a test, what should we do? Put our name next to it?
Yeah, that would be a good step. I think if you want to dive in, I think you could probably just file a bug, and that says something like convert the test home button Mozmill test to a Firefox UI test. Right. So you would file the bug, open a pull request, paste the pull request into Mozilla, and set the review flag. Sorry.
No, keep going. So the process for claiming a test, like I'm just going to pick one off the list. I don't
Sure.
care which one.
Sure.
So you were saying the way we do that is, I mean, there's a Etherpad in front of us. So as a group, we're all looking at which ones you want to do. Should I annotate Etherpad to tell other people?
Yeah, absolutely. So yeah, either start by putting something saying like, I'm working on this test. There you go. Great. And then our purposes for tracking things, you can place that link to the link as you file it. But that's
file the bug that says says, can you continue with that list?
yeah, and let me write them down. Yeah, then you would work on the test in your local branch.
Okay, so file the bug to do it. I need to be spoon-fed.
Oh yeah, no worries, no worries. Yeah. Let me actually give me 10 minutes to write down the instructions, and we'll yeah, this is a good thing actually. Yeah. Yeah. Oh, this is great. Okay.
packet, packet, and I get a message. Yeah. Go ahead.
Yeah.
So it's probably just.
Yeah, I should have mentioned that. The server has been in active development recently, so there were a couple of incompatible changes that landed. So at this point, if you're working with anything but nightly, you're in uncharted waters. Yeah, nightly. Yeah, I should have mentioned that. That's definitely a prerequisite.
Making sure we're paying attention.
Oh no, this is great. Yeah, this is great.
I get reception.
Yeah. Are you working with virtual ends? Oh, okay. That's a great. So Python packaging is sort of screwy. So if you have bad dependencies, it won't always do the right thing. So the workaround of the community has agreed is the right way to do this is something called virtual end. I think there are links under the repo to get it set up. I think that's pretty much a requirement at this point.
Those two space.
It's it's a huge word, in my opinion.
And repo page, the link to virtual end is broken.
Oh no.
Yeah, and I thought it was.
Oh, excellent. How could that? Oh, they must have updated that.
This one is broken. This is a repo page. Mine worked without having to do that.
I changed my Excel spreadsheet.
Oh, the so
Oh,
background is empty.
that's
I figured it might have been just
no, it's the I think there's this issue. So that's a static version. That's probably it's not very good. Cool. Yeah.
I'll buy that for $1.
What's that?
Yeah, so some of it, we'll talk about those steps. You use Marionette tablet, you go away to the bridge. Yeah, bridge. That's the effect, eventual effect of preventing effects. Our test is
Yeah.
so we have a specific.
That's why I was wondering, like, are you actually waiting for everything to fully, all the elements are present, or is it just like, no, it's like,
That's the main.
You're benchmark the search environment.
So now with that, yeah. Wow. Yeah. I really can't.
I think the next thing there is put a break point.
Yeah.
The harness is sort of
Yep. Yep.
I figured I would turn it over to you at that
Yeah,
point.
that's legit. Yep. Thanks, man. Wow.
Yeah. Oh.
Oh. Hang on. This is a silly thing. Rename this test underscore.
Oh, really?
Yeah. It's in the Marionette automation. If it doesn't start with test underscore, it will
Ignore it. Leave the underscore or test?
test underscore. Yeah. Yeah. Because this is for the case where we before we had manifest, we would go through all these directories and just figure out what was the test.
So even though you specified on file on the line as a specific file, it's
Yeah. Yeah.
we won't load it.
Yeah.
Do I? FYI, every Mozilla test frame is this.
Right.
Don't say that because it's good.
I'm going to change that. I actually know how to change that.
Did it work? Is that what it was? Yeah. It should elucidate an error.
Absolutely, yeah. There's just a regex in the. Oh, those are mine. There's just a regex in the harness that says this is the kind of path you're looking for, and so I can change that to be anything, right? So why don't I just do that?
Errors is file test.
Right, right.
Are they? You don't have to tear down that. Oh. That's my question. There was only one test, so it's still I'm looking for example. Which is fine.
Yeah, no, this is great. I think this will be good. We'll translate this into a wiki page when we're done, and then anybody who's interested. Oh, this is the steps. It's sort of a it's sort of a heavyweight review process because we're between Bugzilla and GitHub, so a lot of steps. I'm realizing.
Yeah. The question is if you want to continue with this, with using Bugzilla and GitHub. I think it would be great to get your feedback. It's great to have PRs on GitHub because we have Travis CI running, so you can see if you have introduced some regressions in your code or tests are failing, which is pretty nice. But it simply adds an extra step for us, and but everyone likes the review process on GitHub and likes more on Mozilla, so it's a vice versa. So if you have feedback later for us, I think that would be great. Yeah. So given that I joined late, Chris, any update for me what you're working on at the moment?
Nope. I put in the Etherpad I have some instructions. The section with the bolded targeted tests. That's sort of where I think we can go. If you want access to the presentation I gave this morning, I will link it in the channel. But ideally, we'll be taking a look at Mozmill tests and converting them and getting bugs filed and getting pull requests open.
Nice. Okay.
That's the goal.
So question regarding the assignments for the different tasks. I see that we still have here tests like new tab, close tab, and so on, which are going through shortcuts, menu click, and so on, what we covered in our unit test already. So question is it just a training to get such a test running, or because we still have it in here?
Which test is that?
Like new tab.js where Mark is working on, or test close tab where Matt is working on. I think similar to Rebecca with test new window.
Oh, you're saying that our library tests are redundant with these?
Yeah.
Okay. Yeah. I mean, I think that's ultimately right. But yeah, I mean, the assumption isn't that the tests we have in this initial list for targeted that these provide like really critical test coverage. The assumption is that these are the ones we know we can do, and this is like how we can move forward with them. But that's a good point. Like, yeah, we can move towards other tests, I think. But yeah, at the end of the day, Henrik, we'll have to chat offline about how to deal with situations like that.
Okay.
Yeah, it's not. Yeah, but that's a good point. There will be some redundant coverage in those cases.
So do we have bugs filed for specific implementations yet, or is it still people doing this locally and we do this later?
I'm sorry?
So for specific tasks people are working on, do we have bugs filed for those, or is it just that we hack on this and we do this later once the patch is ready?
So my proposed process is in the Etherpad. Just do these 20 steps and you'll be well on your way. Yeah. So I think that. So what I think we should do initially is people can claim test by putting their nick next to them. That's people are already doing that, which is great. But what I'd like to have people do is replace the link in the Etherpad to the file with a link to the bug that says convert XYZ test to a Firefox UI test, and then So yeah, I guess my request would be that people file individual bugs as we go,
Okay.
and then get a description of the test coverage in a test case as the open comment 0 in that bug.
Great.
And I've asked that they block the 2015 Q1 bug. Is that correct? At this point?
I think that would be let the people file a bug. I will create different bugs. Oh no, I have created, I think, different bugs for tabs, for location bar, and so on. Let me.
Okay. Okay. Well, you're watching the module, so I'll leave that to you.
Let me quickly check this. I have the information in a bit. Okay, I haven't created those bugs. I will do this right now. So we have bugs, meta bugs for tab browsing and for location bar or other tests.
Sounds great.
I will add those to the Etherpad.
So looking at the master bug, which you'd like us to all block our bugs on, that is filed under the testing Marionette.
Is it?
Yeah.
Oh, it was before we had our own component on Mozilla. So I will move this over. Thanks, Mark.
Yeah. If you just want to file it in the component, we're watching it pretty closely, and we'll make the dependency structure the way it should be.
I can file the correct one. I'm about to do.
Okay.
But you're saying there's a top-level component for Firefox UI tests?
It's under
Mozilla QA, Firefox UI tests we have as our own component.
Let me link that.
The tracking bug has already been moved, so you can see if necessary. But let me quickly file the tracking bug, Mark, so that we can depend on blocking the other meta bug.
Henrik, I have a question.
Yep.
I'm just working on, I wanted to start working on test access location bar. And it navigates to a number of pages that I believe are served by like a local web server when the test is running. Is that accurate? So is that going to be in place for these new tests too?
Yeah. So with our tests, we are using HTTPD. Sorry, I was confused with HTTP.js. So yeah, this is a local web server, and we have this already in place. It's working, and you can really do nearly the same. So it's simply navigate. Chris, I think we have some unit tests which make use of the local web server. So I think it would be good to get a copy or a short example into the Etherpad so people know how this works.
Let me do that right now.
So you can retrieve the base URL and then simply extend the URL with the location. So local data is stored under Firefox UI test data. So here we can find all the local test pages. If they are not existent yet, you can take those what we have in Mozmill and simply add them under this location, and then the method Chris will show you in a minute, you can simply load those pages from the local web server.
So if you notice in that list, actually, Bob, you and I are working on the same test. It's been listed twice.
Oh, it's been listed twice?
Yeah.
I didn't even check that.
I know. So I started on it already. I don't know if you want to.
Yeah, well, I've done almost nothing, so I'll just take a different one. I did start to file a bug for it though, but I can quit.
Okay. Have you?
Or do you want to? Why don't I finish filing the bug? Because I've written about half the bug already.
And assign it to me as a QA owner or whatever, or owner.
Yeah, I'll ping you with the thing, and you can take it over. But I'll finish writing the bug.
Fantastic. Thank you.
That's test access location bar.
Yes, correct.
Access location bar.js. Yeah, test. Yeah.
I will delete the.
Thank you.
Let me make sure I didn't do that again.
All right. So then, Matt, you'll need to know this stuff that I was just talking about.
Okay, I've already started on the test, so I found another test that has some similar things. So.
Okay.
Doesn't mean I have it figured out, but I started. So. Thank you.
So the tracking bugs for the individual components, I have added to the M21 as etherpad, right over the list of tests we want to convert. So you can see this. It's done for tab browsing, and I'm doing this now for Awesomebar.
So in the new directory structure for Firefox UI test, I don't see any Awesomebar. They assume we should create a directory.
Yeah.
Okay. Awesome_bar or just Awesomebar? Oh, you guys are killing me. Seriously? Awesomebar?
Yeah, like a trademark or
like German?
Yeah. I use the jargon in the lexicon for way too long.
So I don't have any problems if we name the subfolder location bar. So I think for people who are starting on this project, it makes more sense because they don't really know what Awesomebar really is. And yeah.
So Henrik, you said you don't have a preference.
No, we can use location bar. That's totally fine. Yeah.
Preference is location bar.
Oh, so tests for Awesomebar will go into location bar. Right.
Yeah.
Thank you.
It's better understandable for people.
All awesome bars are location bars. Not all location bars are awesome bars. Maybe.
You don't have a subdirectory called location bar, right? You have toolbar. Off the track.
That's right.
So it goes in toolbar.
Henrik, do you want location bar under toolbar?
Let me quickly think
Or
about
do we
this.
need to rename toolbars?
Well, so what we did in the past was to mirror the different sections in Litmus, the manual test kit system we had before Moztrap. So with all tests were under Awesomebar, so that's why we have used Awesomebar to have a one-to-one mapping. I'm not sure what we actually have now in Moztrap, where we put location bar tests in, or even if we have any location bar tests. That would be the other question. I will check this in a moment. So you are not blocked on this location. Simply create your patch or continue to work on, and we can simply git mv the location of the file with a new folder. That's not a problem. I will have a look at it in a minute.
I'm not blocked, Henrik. Thank you.
Okay.
All right. somebody thinks do, please remind me to end the recording. Yep, we expect that of us. Okay. Great. So paper cuts, things that people run into, and things that I thought of that people will run into in the future based on yesterday. So you need a nightly to run tests. This should have been the first thing I mentioned. The client that we provide with the package is not compatible with older versions of Gecko. There are a couple of changes that landed that mean that an older Gecko doesn't know how to talk to the Marionette client. So this will definitely not work at the moment. The other thing that came up yesterday that I think could be really confusing and disastrous is the test file names need to start with test underscore. They need to start with this exact string, right? If they don't, your tests will not run, but they also won't fail. So, you know, I can imagine this being really surprising and obnoxious. So, just worth mentioning right up. This is a requirement for tests. And then another thing that I came up against last week and spent about half a day debugging, so you don't have to, is there are some tests that will not pass on Travis CI. So when you get to the stage of opening a pull request against the Firefox UI, the official Firefox UI repo, we have tests that run for every check-in, but they aren't running with a real display. And for unknown reasons, the autocomplete pop-up, at least, will not open if you don't have a real display. So at the moment, once we have a different CI system for this, we'll require these to be running in automation everywhere they can. But at the moment, we have to skip these tests. And so our basic criteria is that these tests are all passing locally for everybody involved, right? And then if you do have some cases where you're fairly sure that it's a matter of a UI element that's not behaving exactly how it would with a real display, you can skip them. And there's an example of how to do that in test toolbars. I had to do this for some tests. Take a look at that. What you need is just this decorator here, imported like that. XVFB. Henrik, what is XVFB?
X virtual frame buffer.
Nice.
X system virtual frame buffer, I think it should be.
Okay. So this is what Travis uses to simulate a display. So that's what we call the decorator, because that's the reason it's so so you just take your test method and add this just above it, and this means that the test won't run when that environment variable is set, which we set in Travis, but it will run locally, and so you can verify that these are working. So yeah, that's something that I expect would have come up if will come up.
So it's not only with the autocomplete pop-up here. It's mainly happening for all pop-ups, not notifications. Those should work. But wherever you have autocomplete, it's in text boxes, in the search bar, or wherever else, this will fail. Even in web pages like what you usually have, google.com, and you enter a search term and get a pop-up. That will not work. We had the same problem with Mozmill, but we were never able to figure out why exactly this is happening.
Right. So yeah, given that this was a problem with Mozmill as well, we've for the moment, we're just going to skip these. Cool.
I have a question. Can you decorate a whole class with that?
I think it should work.
Try it. Yeah, my intuition is that it won't work, but Henrik says that it is, so that will. So I would.
I'll try it.
Yeah, yeah. I believe it will not because of the way the unit test framework works, but
Or maybe not with this decorator, but for Moz runner tests, I think I use this to skip whole classes of tests
okay.
if no binary has been specified.
Fair enough.
So the majority of the tests that we're writing in the session will need this decorator, right?
No, don't. Yeah, so don't start with this as an assumption. But if you have, this is sort of the last resort, right? Like we want our tests to run if possible. So push up the pull requests. Make sure things pass. My process would be make sure things pass locally. Open the pull request, see whether things fail, and if they do, and you're sure that they're passing locally, then add the decorator. That would be my process. So we don't skip more tests than we wanted. Could be important coverage.
Or ask us to have a look at the exception which is raised, so we can tell you if it's a problem for the pop-ups.
Okay. Or do we have that exception documented somewhere? Or is it always the same, or is it different?
I think
go ahead, Henrik.
I think it says something about elements not found or so. I think so because it's not getting displayed. You would have to test it. You can yeah, but it's not easily doable. Maybe Crystal has a link to one of those.
Let's not deep dive. I don't want to sidetrack.
Yeah. So looking at this test here, the ones that failed were these wait for conditions, right? So we check for this attribute that says this pop-up is open, and we would just wait forever, and it would never come back, because, or the attribute saying it was open never comes up. So now there you have it. Those are some paper cuts, and then I had some more general comments about our process so far that I wanted to talk about. So somebody brought up yesterday, we were looking at the Mozmill tests, and we're noticing that we had that in some sense the coverage, or at least part of the coverage of these tests were redundant with a different part of the library, that there was there were tests for the libraries themselves, the test libraries themselves that were covering this, and that one of the conditions of the test was actually ensured by the library itself. And so in this case, the question was, well, do I convert this test even though it's redundant? And so I think it's up. Somebody correct me if this isn't quite right, but I think it's really up to us to be critical about what. So there's the case where we can use this as an exercise, right? We're getting familiar with the tool chain. We're able to deploy this in other contexts, and that's useful. If that's not the main use of this for you, I think it's a good place to be critical and think about what should be prioritized in terms of coverage, right? So if you find tests that you don't think are as useful, this probably is something we can document and move on for the moment. That's how I would approach that idea. I don't think there's really any benefit to adding lots of tests that are redundant just because they were Mozmill tests. I don't think that should be good.
Could you give an example of a redundant test? Do you have something in mind?
And there was. Yeah, Rebecca brought it up yesterday. So let's see what that.
It was opening a new window.
Yeah.
And surely that exists inside a user test or somewhere else.
Exactly.
I'm still not confident that I would be in order to test. I mean, like, but you think surely that exists somewhere in the unit test that I would
Tab open test also.
Chris, can you repeat? I'm not. I can't hear the audience again today. Sorry.
Yeah, sure. I need to keep doing that. So there were two examples: test new window and test new tab from the Etherpad that Mark and Rebecca were working on, and those pretty much go through the motions of doing what the tab bar and Windows libraries do. They open a new tab or they open a new window and they check that it's been opened. right? And so that's the main thing that these are doing are probably either covered by existing unit tests. For instance, Moki tests. I'm sure there's somewhere we could find a test that opens a tab. That's not. That's probably not that obscure. And then there's also the tests in our own repo that are testing the libraries that we're providing, right? So under Firefox Puppeteer/tests, there are a handful of tests here. And these are, we went through this process of converting libraries, and as I was doing it, and as Henrik was doing it, we wrote tests for the libraries themselves, right? So you can see this test tabs.py. This goes through the motions itself of opening and switching to tabs. So that's a good place to look.
So in case of the Mozmill test we had before, we were pretty bad in having unit tests for the libraries. So most of this ended up in real Mozmill tests.
Right.
The reason why we need tests like open new tab is that we run our tests in localized versions of Firefox, what is not done in with browser Chrome tests.
Well,
so
yeah.
Usually what we have to test mainly is menu shortcuts or menu entries, shortcuts, and all this stuff which is related to localization. This is the important bit. And what we did here, some of our tests in Mozmill haven't been updated for a long time. So it may be a bit outdated, and if you have questions, you can always ask me if it's related or not. But walking through a lot of those tests have created a good set of methods across specific classes. So let's say for open tab, so you only have to specify, I want to open it via a menu click or via a shortcut or via a click on the new tab button, for example. So it makes it really easy for the test creator to interact with the tabs. And you don't have to retrieve the elements you want to interact with. You have to do the action. And you have to check, okay, has the tab been opened or not? Is it selected, not selected, and so on. All this is magically done by the open tab method, what we now have in our library for the Firefox UI test. So only if you have a specific action you want to do, which is not something default in Firefox, you would have to implement it as your own via a callback function, but that's all.
Right. So yeah, that's a great point. It's not so much that there's a Moki test that covers this. It's that the tests, the Mozmill tests themselves, may be out of date and may be redundant with other Mozmill tests or libraries. That's a great point. That's important too.
So my question is, if you find a Mozmill test out of date, how do we mark that yes, someone looked at this, reviewed it, and decided that it's not worth translating? Do we just have a bug and make comments in it, or how do we check it off the list? I don't think we should do that.
That's a great question.
Can you please repeat, Chris?
Sorry?
Could we just file a patch to remove it from the material?
I don't think we can.
Yeah, so Clint asked the question, can we just file a bug and post a patch to remove it from Mercurial from the Mozmill test repo? Oh, okay, let's go rewind. Rebecca's question was, how do we document this, right? Like, so we can't just decline to convert a test without documenting why that is. So her question was, should we file a bug? Etherpad doesn't seem sustainable or scalable or sufficient. So, and then Clint's suggestion was, why not file a bug and post a patch to delete the test from the Mozmill test repo? If there's no more Mozmill test, there's nothing to convert. So that sort of gets rid of it from the root. Yeah, I think that sounds a good approach. Henrik, what do you think about that?
We don't know how long it will take for us to activate our Firefox UI test via Marionette. So as long as we don't do this, I wouldn't really remove Mozmill tests, because Mozmill tests would still be necessary. As I mentioned, the unit tests we have for Mozmill tests are not the same as what we have now for Firefox UI tests. So we still need those specific tests. So that's something what has been changed. I think the best point here would maybe when I step through and figure out what's necessary and what's not, or Barbara can help me most likely. So that we have to compare what is covered by our unit tests already, and okay, let's skip this test. We don't have to convert this test.
Okay, well maybe in that case, a bug would be good for documentation, and maybe we can eat into you and say, I don't think this test is necessary, and then you can say, yep, it's not necessary, and then we can, you know, we can have that, we can resolve that bug based on that.
Yeah, that sounds good. And I think we don't add new tests for those areas we are covering this quarter. So and that's why we have a fixed set of tests in Mozmill. So we don't have to constantly watch if we have a new test. That will not happen.
Great. Okay. That seems like a reasonable approach. Cool. Yeah. So so this is different. So Rebecca's question was to just confirm that what we're going to do is file a bug for a test that's on our list to convert, and then confirm in the comments that we've decided not to convert that particular test. And I think that seems like a good approach. It's different from what I advocated yesterday, but I think that's good. So every test in the list gets a bug, but not every bug will result in converting that test. And we'll just document as best we can in bug comments that we've said this test is redundant for the following reasons, and we're not going to convert it at this time. And then we can resolve that bug as fixed or won't fix or invalid as necessary.
So in the future, when we're looking for Mozmill tests, we basically find one, and then we'll have to search Mozilla to see if someone else already filed a bug on it, and then do it that way, or is there going to be like a list of actually what's in progress, what's been done, what needs to be done?
So the question was whether when we're going through to find a test to convert, we have to search Mozilla and see whether the test is in, somebody's working on that test already, or whether there will be a centralized conversion list. Yeah, no, the argument is that it's a lot of tests and we don't want to end up with redundant work.
Maybe it's good when I step through all of them and create the bugs for those which we have to convert. So you all know, okay, this test we have to convert, and I will add which steps we need and which steps are covered by the unit test. So I think this may help all of you.
Yeah, it's fairly heavyweight, but I think that a totally complete way to do this would be every test gets a bug, and there's only one bug. And so we follow
I think
front.
time-wise, that's the best because I know all of our tests, and you would have to investigate, and I can quickly say what's necessary here.
Yeah.
So we can.
And also, Henrik and I are watching the Firefox UI test component at this point. I'm looking at all the bugs that come through there. So if there are dupes, we can hopefully catch those on an ad hoc basis. Yeah. So there is a master bug. So Rebecca was noting that it would be really helpful to have bugs, and so I think we're at the moment we have the 2015 Q1 tracking bug for tests we're targeting this quarter, and then blocking, and then that's blocked by. Sorry, that depends on some individual tracking bugs for directories, and then that depends on individual bugs for individual tests. If they're not, let's add them right now. Ah, yes, they are.
Yeah.
There's each above each of the sections. Henrik put down. Great. Okay, the other question that came up again this morning, that came up a couple yesterday. It was about the libraries we're using and how to access them from within tests. This is something I noted before is not in the API reference at the moment. So this exact string, this exact expression is how you get to the URL bar. So if you remember yesterday, we found the URL bar element, we sent keys to it, we clicked on it, we went through that exercise. That actual element is accessible. A reference to that element is accessible from within a test with this exact expression. So you have to go through self.browser.navbar.locationbar.urlbar. So these are each classes. Each step in this chain is a class, and each class is an instance of a class. And each class has its API reference in this location, which is the read the docs for our libraries, right? So if I want to figure out how to get to here, I have to sort of know that this is in, and this is where we need to improve our docs, but I have to know that this is implemented as part of the toolbars library, and then I have to see that there's a nav bar that has a location bar member, and then see that that is an instance of the location bar class, and then from there I can look through the location bar class and find, and these are alphabetical, the URL bar element. So that's one way to get to the exact expression you need to reference those objects. The way that I would do it, that I think might be a little easier, is to go through those tests we talked about a minute ago. Because we've written tests as we've gone, writing libraries, you can find, for instance, in test toolbars, that expression will appear. So you'll see here that that's how I got to it, and this is how I'm using it in an actual test. And I think that should be a decent enough way to get it. Okay, any more questions about the way we're using libraries? The main thing that came up is that people are expecting to need to import these into the scope of their file, which is a totally reasonable expectation. But we've provided these shortcuts to instances already, so that's not necessary for a lot of these cases. Excellent. Okay. At this point, I'm going to solicit any more questions that came up from yesterday. Any topics at all?
I have a few questions.
Yep.
I actually added them to the schedule Etherpad so I wouldn't forget them.
Great.
So the first one was simply in terms of the style of how we're writing these tests. Is it going to be one file per test, or are we going to have some files that have multiple tests in them?
That is a good question. I think that came up again yesterday as well.
So the standard is multiple tests per file. Sorry, I've been kind of lurking in the background here.
Oh, hi, Andrew.
So like we use the unit test framework for a lot of our internal tests, like Marionette and Mozbase, and those are all kind of one test class with functionality broken up between a test method. So if what you mean is like the methods as a test, then I would say multiple per file. But I guess it's kind of up to you guys how you want to structure it.
So
variations on a particular test should be one file, but it should be with all related stuff.
Yeah, so Mark was saying variations on a test, related things certainly can go in one file. In terms of the scale, I think the Python tests that we have in the tree that I've seen would correspond to about a directory's worth of Mozmill tests in a lot of cases, right? And then each individual file that's a Mozmill test would correspond to testing about as much as a test method in a Python test file. So that's my intuition for how this would translate if we're going to follow the style of other Python unit tests, but I don't necessarily think that's the best idea. I think for tracking purposes, since we're working on these concurrently, having separate files might be a pretty decent idea. Just, you know, if we did put all the awesome bar tests in the same file and we all try to work on it at once, it would be a mess of bit rot. So yeah, that's not a completely definitive answer. Does anybody else have an opinion about that at the moment?
So I think I agree what Mark mentioned here. So if we have a specific test for a feature which might have variations in the test, a simple case, for example, opening a new tab, so we have menu shortcut or whatever else. Maybe it's good to have separate test functions inside this module. One problem I see here is in Mozmill we have had hard and soft exceptions. So with soft exceptions, the test would still continue. We had to use this because it's more helpful for us. If the test is not blocked, we have raised soft exceptions like checking for properties for an element, which actually should not cause your test to stop. Only if the click and the expected behavior does not occur, then we stop the test. We don't have this, as far as I know, with Python. So having multiple test files in the same, having multiple test functions in the same file might be helpful, I think, here in this case.
Okay, that's a great consideration. So my understanding of the way the Python unit test framework will work is that if an exception is raised, it will interfere only with a method, right? So a single test method will stop at that point, but it will continue with the others. So that so we'll need to translate that to the needs of the Mozmill test. Does that make sense, Henrik?
Yeah.
Okay. All right.
I have no idea if there is a way to have warnings or something like this in Python to make sure that we can check multiple things without stopping the test, or if it's not a valid case, how it's usually done with the test case in Python.
Right. So yeah. So I think the answer to that will be splitting things into smaller test functions, because any exceptions that are raised in the individual test functions won't stop other test functions. Okay. So I think what we can do with this is say that in general, a Mozmill file should translate to a Firefox UI test file. A .js file will become a .py file. But we won't assume that the Mozmill tests are factored exactly the way they should. That if we find an opportunity to combine multiple Mozmill tests into a single .py file, that we should absolutely do that. Okay, good questions this morning.
I can describe my second question.
Great.
So the reason this was raised by me was I was working on a test, and what it does is it chooses a menu item to add a bookmark, and then a dialog pops up where you have to click the done button. And so I was able to figure out how to click the done button, just by finding the proper locator and just saying, find element and click it. So the question is, in a situation like that, should that locator be defined in that test, or are we going to be building objects that support that? So, we would have a bookmark panel object that all the tests could use. I believe that's the way it was done before in Mozmill, and that's what we usually do with the WebQA test, but I'm not sure how you want that to be approached in this project.
Yeah, so I think you probably found a place where the libraries we've been building, there was probably essentially something missing. So Yeah, absolutely. We want to build test libraries, much in the same way that we have them for Mozmill, or I expect you guys have with WebQA. So I think in cases like these, we can do it as we go and add things like selectors for menu items. And I actually have and I'm going to talk about a way to do this this afternoon. We're going to go through making a library together to put selectors together. And I guess the only question there is whether we need to have a separate issue for adding library items, or a separate bug for adding library items versus converting tests. And I think we probably don't, so long as we're considerate of how the selector might be used in other tests. Yeah, so Matt was working on a test yesterday and noticed that the selected index attribute from the autocomplete results element was not included in the library. It was omitted. So we can get access to it, but it's just something that we'll have to add to that library.
Okay, so then in that situation, there's an existing library that's missing some functionality. In my situation, there isn't really a library anywhere where that would belong currently. So then it comes to, architecting that and deciding, where it should go and how one would even get access to it. Like, for example, the way our WebDriver tests, what generally happens is we would have an object that represents a page, and then if you're clicking on a button that takes you somewhere else, then the method in the page object that allows you to click on that button would actually return the next object to you so that you would have it to work with. So I can imagine selecting a menu item would return to you the dialog that you can then interact with, although I don't believe that's the way it's architected right now. I think it's a menu item that just selects it.
So the situation you have described here, we actually have with any kind of window object, like the browser window, and for tabs. So if you call browser.tabber.openTab with whatever you want to open the tab, the new tab will be returned. So you can directly use a new tab and do a click or get elements from it or whatever you want to do. And the same have we implemented all the stuff in Mozmill. Not all the libraries we have in Mozmill, but we did a lot of refactoring in the last couple of months. So this is really something we also would like to have in our test. So it makes it similar to the test you have and for Kaya UI. So people can easily switch between our projects to help us implementing tests.
Yeah. So in that case, that there's a whole library that we haven't implemented yet. If for the purpose of an individual test you want to keep the selector local, I think that's probably acceptable. And we might want to just file a bug if it exists in a Mozmill library, to convert that library or to make a new library, and then we can have a separate bug where we talk about a way to do that makes sense.
Yeah, that sounds like a good way to move forward.
Great.
Okay. That brings me to my next question, which was about localized builds. And right now we're clicking on menu items and we're using the label in order to tell it which menu to select. And there's a comment in there that says it won't work on localized builds. I don't know, is the intent to run every test on localized builds, or are there only certain tests that will want to run on localized builds?
So the actual menu library is not up to date. I wasn't able to make it compatible with localized builds. I would suggest for the moment simply to get the ID of the menu item and issue a click on the menu item ID. So you can use set Marionette find element ID and the ID of the menu. So you get back the element, and then do an element.click, which will simulate a menu click. The update for the menu library is one of my next items I have to do. So it will happen by next week, I think. I won't be able to get to it by this week. So once we have this, you can simply give an ID, and it will automatically get the correct entry and click on it. Even for dynamically created menus, depending on the context, what you have, all this will be done automatically by this class.
Okay.
That's a good question, because we had some trouble with this with Mozmill 2 in the past, and it has been taking a while to get it working.
Okay. I believe that was my last question.
Great. I can't tell from the Etherpad whose question this. Oh, okay. Rebecca has a question. Can I just read it? This looks. Should I just read the question? Or okay. So
That is the question.
so the question is for individual test bugs. Can we prioritize these as Q1 goals?
No, I mean, like, I don't understand which one.
Right.
And in some areas are definitely on the Q1 list, other ones are not. We can prioritize the bugs in a way to like that. So that we know it's working.
Great.
Can you repeat?
Okay. So the question is, which bugs are targeted for this quarter? Which tests to convert, so that we know what to work on first. And yeah, or if they're all Q1 goals, we should proceed accordingly. So that's the question.
Okay. So for this quarter, we have mainly two goals to convert all the tab browsing and all the awesome bar tests. We have one other goal which we might not be able to fulfill is for the search bar, but it's really not really something which is on our official list. If we are able to get to this, it would be great. But given that Softvision was not able yet to create Mozmill tests for those things, it might be harder for us because we don't have a working library we can base off. So tab browsing, awesome bar, and the update tests, which I will cover, are the quarter one goals for now. I would propose that we, when we file those bugs, we set the priority into P1, so we can make sure that we can check for those bugs and say, okay, those are important for us to get done first. Does this make sense, Rebecca?
Yeah, that makes sense to me. So I think the answer is for our purposes, it's those entire directories. So so it's everything on those lists. With the exception, I stuck the toolbars, the two toolbars tests in there as well, because I thought they would probably be viable to convert in case we ran out. But those don't have a tracking bug associated with them. And Henrik has the 15Q1, it's called, bug that just says convert the first set of tests, and so all of our Q1 bugs. Are these all goals blocking this?
Yeah.
Okay. Yeah. So all of these bugs that block this are Q1 goals, and so yeah. But again, if not every bug will result in a conversion. So it's just a matter of one way or the other taking them off the list. Cool. Okay. Any more questions that didn't make it to the Etherpad? Great. Let's break for just a few minutes, and we'll come back to demonstrations. We'll pick up where we left off with the wait class, and then we'll talk about how to use the Python debugger and see how far we get with that this morning. And then this afternoon, we're going to talk about how to use the browser toolbox. to inspect the Firefox UI, and then how to use that to build our own library, find the appropriate selectors, and talk about why that's a good idea to do. Yeah, so I'm going to get a cup of coffee, and we'll come back together in about 10 minutes. Yeah. Who knows what people...
You hear us? Test, test. Maybe you have to rejoin. Oh, yeah? Yeah?
Okay, can you hear me now?
Yeah.
All right. Okay. Oh, and we were recording through that. That's excellent. Okay. All right.
Is there a link for this slide deck you're going through today?
Yeah. Oh, yeah. That's a great question. I didn't do this yesterday, and I really ought to have. But before, I'm not sharing my screen. That's also a prerequisite. Okay. So I ought to have done this yesterday, but the training schedule I'm updating as we go with links to the slides and then also with links to the branches where you can get the actual files I'm working through. So it's my intention that you have access to the files I'm working through, and you can follow along if you so desire, and you will find that useful. And that's just a matter of checking out the branch. I have each one on a separate branch, so I can push them up and work on them separately. Cool. So we're here at Wednesday morning, and the presentation is unit test. Yeah. Great. This is what I was going through this morning as well. So great. Let's pick up with what we were working on yesterday with weights. If you remember, we went through the process of navigating with Marionette 3 or 4 different ways. And one of the main point I was trying to get across was about things that are asynchronous that we need to wait for under certain circumstances. So the thing we saw yesterday to do this was wait for condition, and we have a similar, and just so we're back up to speed, this is the failing test case. So we have something that uses JavaScript to navigate. That's the effect of running the script. That doesn't happen by the time the script is over, but will happen at some point after that. And then we have the couple lines of test that assume that as soon as this returns, as soon as this navigation function returns, the URL where we have the location of the current content window is our destination. So let's run this and make sure it fails. Okay, and it fails with the error we expected. We were at about blank, but what we wanted was our final destination. So the way we sought to do this yesterday, it's rather verbose, but we can make our own local function and wait for that to return true. It just gets called over and over again by the framework until it returns true. And again, the only argument to this function is the Marionette, is the brain of our test that gives us access to pretty much everything. So okay. And we can safely replace assert equals with the wait for condition. The wait for condition will fail if this never returns true. So it doesn't look like the other assertion functions we have, but it's giving us what we need.
You put an error message in there if it fails in the wait for condition as the optional second argument, while you handle the assert equals?
That's a great question. I don't believe so. I would have to look at the implementation of wait for condition in Central, which is actually easy enough to do.
It's only a method and a timeout.
Okay, yeah. So this is what I mean. Yeah, why not look at this actually? This is what it's doing under the hood. And you were right, it defaults to 30 seconds. So we get it calculates the end time that it can't go past. This time.time is just getting the current timestamp. I think it's based on seconds in Python, but yeah, and then it calls the method, right? So you see this is our the first argument here, the method. It calls this with its own Marionette as an argument, and it does this in a loop. It does it over and over until it. Oh, right. Okay. So this is a little bit of Python magic. You can put an else after a while. Let's not worry about that for the moment. It's just good enough to know that the timeout exception gets thrown if this evaluates to false, right? So if we go past the end time, it sets like the global date where after this point this has failed, and it will raise an exception. Cool. Yeah, but that's something that may be available to the wait API. So the next way we have to do this, that might be a feature. Okay, so so that's one way to do what we need to do, and let's make sure it happens that way. Okay, and that worked out just fine. And we remember yesterday we printed out every time it ran that code, and it just had to go through twice. It ran through. Second time it passed. All right. So there's a slightly fancier and better API for this that's provided in the wait class. So let's look at that for just a minute. And so this is the import statement you need to get it from Marionette import wait. So then wait is just an object with a constructor that takes one argument, so it needs Marionette, right? Everybody needs to talk to Marionette. That's the brain of every test at pretty much every point. So you get one of these wait objects, an instance of it, and you just call until, and this is a similar idea. And so this lambda here, you'll see this around. You can choose not to use them. This is just another syntax for a local function in Python for defining a function. So if you sort of squint at this, you can think of that as def without an identifier. So there's no way to refer to this outside of this scope, because this is a really pretty short thing we need to do. This is just a simple idea that can be summed up sort of concisely, right? This thing equals that thing. And there's no need to give this a name like we did before. But I can tell you that this function I guess the best way to put this is that this function, I'm done, is the same function as this. These are doing the same thing. The lambda's a little funny in Python. The thing that goes in the body here is just an expression that will be the value that it evaluates to. There's no return statement, and you can't use anything that's considered a statement context. So you can't use if then, if else blocks. You can't use while loops in lambdas. You can't do a lot of powerful things in lambdas. You need to have a named local function for those. Anyway, that's basically the digression. This is about as much as you need to know. To do this sort of thing with Marionette. The fallback when a lambda gets too long and complicated is to create a local function. And we do that. You can see examples of that in some of our own libraries. We use waits because we don't have an observer library quite yet. In the tab bar and in the Windows libraries, we use wait. Yeah, and so wait, it has a default timeout of 5 seconds, which is pretty appropriate, I think, for UI interactions, more so than 30 seconds. And it allows you to configure it in fun and interesting ways. So just for fun, I thought what happens when give it some interesting parameters. So here's a different kind of wait that has a timeout of 1/10 of a second and an interval of 100th of a second. And let's see if this works. I actually don't know whether it will. I need to. Aha! That wasn't long enough. 1/10 of a second was not long enough to get far enough. So anyway, so this is all tweakable, and this wait class is documented in the Marionette API reference documentation.
Quick clarification. In the lambda, the argument m, what's going to get passed in is self.marionette.
Exactly.
Okay.
Yep.
Thank you.
So so I could do this, and that would be equivalent.
And so if this times out, you get a similar generic timeout message as you would with wait for condition?
Yeah, let's wait. Yeah, we just saw it. It looks almost exactly like we said.
Timeout exception.
Yep. Yep. Okay. So that's it for waits. That sums up what we were working on yesterday. Let me make sure I'm right branch for.
Yeah, that's a good question.
Yeah, sure.
It seems like you'd probably want to avoid a lot of these waits, though, because when you have genuine errors, just a simple timeout sometimes doesn't really give you a lot of information about what happened. It seems like you'd probably want to move away from time-based tests to event-based testing.
Absolutely. absolutely. And we're working on, it's a little difficult to do in Marionette, but I think we have a viable workaround. We're working on an actual library that will allow you to register observer and event handlers. So that will talk to Gecko about what the, and so what we can wait for is that event itself, or that observer to have fired, in order to know when to proceed. Because yeah, in a lot of these cases, the waits, we're waiting for the obvious UI side effect of the thing we care about having happened, right? We're waiting probably longer than we have to, and we're polling at like arbitrary intervals. In terms of a better message, let me see if there are parameters to the wait class that will. That's the wrong wait. Okay. No, I guess we don't get special error message. That's a shame.
Well, it seems like you could still use wait for very sort of large things that just simply have to happen.
Right.
And then if you want to get specific about things you are checking for, that's when you check properties and states of things.
Yeah, exactly.
Specific assert statements. But I wouldn't use a wait statement for something that was a very important detail of the test.
Sure. And the other thing you can do if you're interested in having a really identifiable error is you can put this in a try block and catch the timeout exception and then call fail. So I think the Python unit test there's self.fail, and you can put a message in there, and that will raise the appropriate assertion error to fail a test. Cool. Great. Okay, so what we have for this morning is talking about Python unit tests, and mostly what I'm gonna go through is how to use the Python debugger. So we were using sleep statements yesterday just to see that our tests were running, and Mark pointed out made a good point that even for testing, if you put sleep statements in just to see what's going on, the problem with them is that sometimes they don't. If you put them in your code, they might stay there. They might get checked in, and that's really bad. So pretty much, I'll say that you shouldn't have to use them. If you're comfortable using the debugger and you can see things line by line as you type them in, having the effect you want, you can get something equivalent. So okay, so we saw this yesterday, and I don't think I think this is mostly going to be a review for us at this point. So the other thing that I should have mentioned yesterday, and you'll see in all of our tests, and something that I've forgotten to do and causes confusing problems, is that if you provide your own setup and teardown, you have to call Firefox test case.setup and Firefox test case.teardown yourself within the setup and teardown methods. And this is something that I think you will see.
Those methods we call after you do your own.
Right. So in the case of setup, you call it first. Yeah. So yeah. So in the case of setup, you have to do your own. And then in the case of after you call the superclass, and then in the case of teardown, you should do your own before you call the teardown. This came up yesterday, but neither of these are convenience. If you find yourself repeating code a lot to make sure that the test environment is what you want, you should add a setup method that does that and make sure that the state is consistent between the executions of the test methods. So for instance, I was writing a test for the toolbars library, and I found that I needed the URL bar to be clear for every single test. So there's a setup method that just clears the URL bar before every test, so we know what we're working with. And yeah, if you're interested, so you've probably noticed that there's something called setup module and teardown module in Mozmill tests. This is a little bit different from our setup and teardown. Our setup and teardown run before and after every single test method. Setup module and teardown module, unless I'm mistaken, will run at the beginning and the end of a whole test file, and sort of mess with global things that the test itself needs. So there is a similar facility in the Python unit testing framework called setup class and teardown class, and those will run before and after the entire class runs.
So for a quick input here, the reason why we have had setup module and setup test in Mozmill is the reason that we can do restart tests. So now with having the test in Python, we do not need multiple tests for a single test. Like let's say for updates, with Mozmill we executed the test in the browser itself, but for each restart of the browser we needed a new test, and that was the reason why we had to differentiate between setup module and setup test. So setup module is the same what Chris mentioned here for setup class in Python, and setup test in Mozmill is equivalent to setup module here in Python. So but given that our test is now running outside of the browser, we don't need this differentiation anymore. So that's really a good thing. So we only have to rely on setup test and teardown test.
Great. That's good. That's good to know. How does, out of curiosity, how does Mozmill know which functions are tests?
We use those methods which start with test.
All right. Okay. So we found this yesterday. We were talking about this yesterday too. The unit test library does exactly the same thing. So your test method needs to start with the letters TEST, or it will just not run unless called. So that's a critical point there. So if you want to have helpers that will do certain things that themselves may have assertion functions in them, you can, but you should not have them start with TEST. You should have them called by a method that starts with.
Sorry, is there a mistake in your slide there? It says setup class runs before or after every method. Doesn't it just run before the first method and last method?
Yeah, sorry, that's absolutely correct. That should read before after all the methods.
Oh, it's not the same.
Yeah. So yep. Thanks, Andrew. That's a good point. Yeah, I think that's technically ambiguous. If every means for each. Okay. Yes, that should read they run before and after all of the methods. Cool. So we've already seen a lot of this, and I talked about assert raises yesterday. But these are the kinds of things you can do. And there's a lot of different methods that have a lot of different functions in the unit test API that do lots of interesting things or not so interesting things. Mostly, each of these is implemented with something that will do a comparison, simple comparison using the equals function or is or in, and it will then raise an assertion error if it doesn't get the expected result of evaluating that. And you can see documentation for the library has lots and lots of information about this. There's a API docs, right? And here's a table that has assertion functions and what the equivalent Python expression is that it checks. So I think that's sort of interesting to know how this is implemented. And so so what I have as an exercise, if this is interesting to you and you want some more sort of practice with sort of the essentials of Python programming. So my first challenge would be to take the methods that I have here and implement them within your own class, and you can implement them in terms of a different syntax, which is this syntax, the assert syntax, which will take an expression, and if it evaluates to false, it will raise an assertion error with a message, and it will give us that core functionality is enough to build a library much like the unit test API. And along the same lines, I'm not going to go over this with the group, but I pulled in some tests for the assert raises implementation from the standard library itself and put those in a file. And so the challenge there, the exercise, is to implement assert raises in such a way that it passes the test for assert raises that are in the standard library. That might be of interest. Okay, so again, test methods start with test. They don't run in any particular order. I mentioned this yesterday. By experiment, I've determined that they run in alphabetic order according to the method names. This is a matter of style and opinion, but I would assert that test methods should be short. I think that short test methods are easier to write, they're easier to understand, they're easier to change, and they're easier to debug. And I think it's important because when they fail, they don't fail. It's easy to know what's wrong. When a short test method fails, it's much easier to know what's wrong, and it doesn't interfere, like we were saying, with the other tests. It doesn't necessarily interfere with the other tests in the file. It could still, if it leaves the browser in a bad state. And so, yeah, it's pretty short, but I think 25 lines of code is a reasonable size to target. Much more than 50 is probably getting a little out of hand. So you can look for ways to split that up into helpers or to split into multiple tests. That's all a matter of opinion, but that's a good rule of thumb for that. Okay, great. So debugging is a big part of this, right? Like this is the sort of essential experience. We have something that either fails or passes when it shouldn't, and we need to figure out what state there is between the Python client and the browser that's making that happen. So the basic way to inspect the state of the running program is to print out information, right? So let's say we have an assertion that's telling us we have the wrong number of windows open. So we want to see how many there are to know why that's wrong and what their IDs are. So we can do things like this and just print out information as the test runs and then inspect it later. To really look at something as it's happening, but there's no replacement for the Python debugger. It has some sharp edges and doesn't work exactly as you expect some of the time, but it's still an invaluable tool for this purpose. Cool. And so the debugger, it just stops the test and opens up a place where you can type in code that will be run. And it has some special commands in addition to that. It will let you do things like, it lets you sort of in an ad hoc way control the control flow, step through the function and see what it happens. So I have a short example. Lift up the font. Okay. Yeah. Okay. So I was working on toolbars, and I needed to convince myself that when my test, I had a test that was testing that the pop-up opens, right? That test we were talking about that fails always in Travis. And I had to convince myself that the pop-up really was open in the browser UI when my function said it was. So to do that, I wanted to see it happening, right? Seeing is believing. So one way you can do that is with debugger. And so let's just go through the steps to have that. Cool. So I ran my test and it stopped midway, which is actually what we want. And to make this happen, I need this little magical statement. So Python debugger PDB is short for Python debugger, and it's in a package called PDB. You have to import it, and then the main thing we'll do, you can do lots of fancy things with it. Mostly what you want to do is this. You set a trace, and that means stop the world and let me type commands into the prompt. So if we have so this is our frozen test case from before, and it's corresponding to this browser that's open. This is the nightly, so you've noticed I've been using Developer Edition. This is a totally separate browser. This is the one that was launched by the Firefox UI test framework. So this is a pretty cool thing, actually. If you see an Emacs here, this is that function, right? So this scope of what I can type here is that function. So I have access to everything that it has access to, which is pretty nifty. So I defined here for the purposes of this test the pop-up and the URL bar elements. So I have these. That pop-up element and the URL bar, just an element, right? So I can do fun things like call methods. I can enter a URL, and you can see in the there's some lag in the video, but you can see that entered it, and then I can.
Sorry, I have a question.
Yep, go ahead.
And maybe it's just me and my setup at home, but video prints the name of the person that's sharing the screen, and yours says Christopher, and it's directly over your command prompt. Like I can't actually see what you're typing.
Thank you for mentioning that.
Perfect.
Is that better?
Oh, gorgeous.
Thanks very much. Okay. And then that will take us to, I should have taken this to about home. Maybe it needs focus. Anyhow, great. So how do I make this thing open? Right. So what I need is this guy we know and love, right? The pop-up is this thing, and so I need to think about what the expected interaction is that will cause that to open. And I guess there's some default history in here. So the A key gets lots of matches, so no problem at all. And I'm in the debugger, so I'll just send those keys and make that work. All right. So exactly. So this is a little tricky, but we're not going to be able to do this without focus. So I'm not going to give up there because I still want to know that my autocomplete function is working. So I still need to see this, and I want to see it happening as a result of things I type into the prompt. So I'm going to use a sleep here, and this sleep is not at risk of getting checked into anybody's code. So I'm going to give myself 2 seconds to give the URL buff focus, and then I'll confirm. So Python lets you separate statements with semicolons. It's not idiomatic. In fact, we have a linter that runs that will fail a build if you do this in code that you check in. But for the purposes of the debugger prompt, it's pretty necessary. So this just says, give me the time library, sleep for 2 seconds, and then send the keys that you wanted to send. So sleep. I'm going to click over to here, and there it happens. Right? Great. So that got us as far as opening the URL bar, and then I think.
Can't you get it focus programmatically?
I'm not sure of that. Henrik, do you think that's something we could do from?
So I think that might be an underlying issue with Firefox. Maybe, I'm not sure. It actually could be the reason why we fail in Travis. That not sure if we have a headless system running our test, that we don't have actually the focus. we have the focus testing mode, but I think it's enabled, right, with the prefs. If not, we should do it.
Oh, I'm not sure. I'm not sure about that. So so there is a focus. Is there a focus? Not find there.
Oh, we don't set it, I think. Oh well, Marionette should set this preference, I think, by default.
Okay, we should file a bug about this. Let me see if I can call focus on the element and have it work. So my intuition about this is that it's not going to be possible to execute a Python command in the terminal program that causes Firefox to steal OS level focus. That's sort of, somebody else might know this situation better than I do, but that's my intuition about this, is that we actually wouldn't be able to in this exact situation. In general, what we can do, and we do in some cases, is change what, if Firefox sort of the program has focus, we can change what within the program has focus, right? So we have the ability to change focus between Chrome, Windows, and tabs. But I think in this particular case, we're not going to get that. But I'm just going to try. By the way, you have 3 teams. Oh, that's going to fail. Thanks. Glad you guys are the yeah. So right. So this didn't raise an error. Focus is an element of this. Is a function on this element, but it didn't steal the focus from the terminal program I'm working in. That's a good question though. So in any circumstance where an automated test is run, we can programmatically get focus. This is sort of a demonstration thing because I'm paranoid that my autocomplete function is not working. Okay, yeah. So Andrew pointed out on IRC that this is there's a pref that. Oh, okay.
So
okay,
if you're using Firefox profile, it should get set for you. So.
Yeah, we're not in Marionette. We're rolling our own set of prefs. So that
As we inherit the default from Marionette, so it should be present. At least you can open about config in the browser and search for focus. Oh yeah, you can do it right now, right? Focus testing mode. Focus manager test mode. The second class. It's true. Okay.
Okay, and so you're saying that this will let me steal focus?
Usually.
Possibly.
Possibly. Usually, possibly. Okay, let's all right, so. Yeah. Good to know. Okay, so does this look right to you? If I tried to use the usual focus function, it would be. Let's give it a shot. Oh, nothing happened. Okay. Okay, worth looking into. But anyhow, so yeah, I can't. So that's my. I can't remember what the thing I was testing was for that. Is open. We'll leave that. Great. Okay, so that's the question about bugger. Oh yeah, and the point is, whatever I type. Whatever I type into the debugger prompt is something that I can then put directly verbatim back in here. So if I did URL bar.send keys, and so this is the same context. We can do this. So so just to show what a few other commands you can do with this, we can also step through line by line, right? So I just set the breakpoint at the beginning of this function, and so I can see that I'm frozen right here, and so this prompt tells me the next line that's about to be executed. So pop-up is about to be set. It's not set yet, right? So I can what's it called? Next. I can type next. And so that executed 2 lines of the function, and now pop-up is defined. And so this can do pretty cool things. And if you want to, you can step into functions as they go. You can return, and you can continue running. And this is where there's sort of a sharp edge with the Python debugger in this particular environment. I'm not sure why this is, but if you try to run from where you were, don't expect that test to pass. There's this exception. I don't. Does anybody, Andrew or Henrik, have you seen this? No way around this. This is annoying to no end.
Don't you usually type C for continue?
Not usually. Great. Don't use run. Use continue. That's thanks, Andrew. That's the great. So that's all I had for formal demonstration this morning. I think yeah, the main takeaways are, for me, don't use sleep. Use the Python debugger anytime. It's almost the first thing I do at this point. When there's a failing assertion, put the debugger statement in directly before it, and see what the values are that they shouldn't be. That's my general strategy at this point. And yeah, so that's it for the moment. Do we have any questions about using the debugger or anything else at the moment?
So with regards to don't use sleep, what if there's like a wait condition that's not implemented in the libraries yet? And can you sleep temporarily until that gets implemented?
Is this something that you couldn't use a wait object for?
I don't know.
Okay. So my position on that is that almost always you can wait. You can use the wait function that will pull and fail a test when it fails instead of sleeping. So it's just a matter of figuring out what the state is that you need to achieve. So in our case, when I was going over waits earlier, so this is a place I could also use a sleep. So instead of polling and returning true when this state is met, I could have left the assert equal assertion in this function and just put a sleep. Just said, well, wait for 5 seconds, because clearly, it's almost an equivalent. It's almost an equivalent test, right? Wait for 5 seconds and then do the assertion. That's sort of kind of what the wait is telling us to do. So you could do something along those lines. Wait is good because it polls for you, so you don't. So 5 seconds is like the worst case scenario. It'll be faster in a lot of cases. Yeah, but if you if you really, it may well be that there are cases where you really need to coordinate things, and you have a sequence of inputs, for instance, that you don't have an easy way to know when to proceed. I guess that's the case where you might really need to sleep. When you have a sequence of inputs without outputs that you can rely on to indicate you've reached the right point. So in that case, maybe you would need to sleep, but I would be hesitant. I'd be hesitant to add them. You know, it's the last resort in my mind. Andrew, have you come up against things that you think are legit uses of sleep at this point?
Actually, maybe Bob can answer this because I was reviewing one of his tests, and apparently there's something missing from a bug that. You know what I'm talking about, Bob?
Yeah, it was actually Henrik who suggested doing it. It has to do with something that's missing. It's something that's going to be coming in the places module. It has to do with being able to wait for observers.
Yeah.
Yeah. So as I think as long as we have a property or an attribute on a DOM element, we can wait for. We should use wait for condition or the wait for class. But if we have to depend on an observer or event, there's really no way to wait for something because you would have to register and listen for this event or the observer. That's not something we can do at the moment. So only if we have this condition, I would say let's use sleep and really mark it at the comment above with the to-do so we know where it belongs to, and so we can remove it once we implement the library method for this.
Okay. So I'm totally sympathetic to that. In principle, though, couldn't we, because we have access to all of the components, couldn't we run some JavaScript that told us how big the places database was, for instance, and wait on that? Just in principle.
Places is most likely one of the most complex things what we added earlier.
So this is a place where we can say that, like, even though there's some browser state that would indicate it's time to proceed, it's just not worth. It's sort of not worth the effort to get to that. There might be
a way to get the information out of the places database, especially if you want to check for a visited page. But you would have to do a bit of queries to be sure to get to this information, and it's, I think, a bit complex to do.
Yeah. So that's a question of going through Gecko APIs and seeing what they're trying to do, which is not always a straightforward task for sure. Cool. Okay. Yeah. So and also and that's fine also because we have another way to do this that's in progress. So as long as we have a to-do associated with that, observers are legitimate to achieve that. Okay. Thanks for bringing that up. That's a great point. Don't like to carry around absolutes. That's great. Okay. So should I stop recording for now? If there are no questions, and we can continue with our tests. Great. Okay, so what I have for this afternoon is a relatively brief demonstration of using the browser toolbox, which is basically dev tools for the browser UI, which is I found very, very helpful when trying to find, particularly for finding selectors for UI elements that we can then use in our tests and our libraries. So I thought that was worth going over. And so yeah, this will be the last full group meeting for the training this week, but I will be around in the office and online tomorrow, and we've explicitly earmarked that as time that will be available for questions for working on this. Yeah, and we'll see how far we get. So I made a note in the schedule Etherpad. It has the, let's see, the last presentation here, which is very brief. It has a link to the examples, which this file that I have is primarily for if people want to work through. We'll work through one or two pieces of it together here, but I'll leave the rest of that as a takeaway if you find it useful to work through those and compare them to the libraries you're working with. You can have at it. And then finally, I made a short exit survey, just about 5 questions, so I can help, just to help me and the rest of us on the A team gauge how we're doing and how we can proceed. I wrote this myself, and hopefully it's anonymous, but yeah, please be candid. That's about it. Can somebody confirm they can access that? This is my first time using Google Forms.
Yeah, it works.
Awesome. All right. Yeah, so let's get started. So yeah, we're going to talk about, like I said, the browser toolbox, which is DevTools for the Chrome, the browser Chrome. Getting it turned on, using it as a inspector for the markup elements in the UI. It also has a read eval. It has a place you can evaluate random JavaScript in the scope of Marionette, which is helpful. We'll talk a little bit about anonymous nodes. I'm an expert in the topic, but I can help you find selectors, use them to find selectors, and then talk a little bit about the libraries and how we're doing those and why. So yeah, this is the usual DevTools suite. We're sharing a lot of the tool chain between regular web content and the browser. Zool is a markup language like HTML. We use JavaScript. So applying the tools is not trivial, but we're able to do that. It's a really powerful tool. It is occasionally flaky. I found it's slightly unfriendly to the user, and particularly with E10S on. You will find sometimes there's limited support. It was broken for a while. It does work to a large degree, but it's difficult. Yeah, I won't vouch for its level of support with E10S or not at the moment. But that being said, it's really powerful, and I don't think I would be able to have gone through the process of making UI libraries without it. The alternative is reading the static Zool files and XPL and XML files and sort of trying to relate that to the UI and statically, and it's not nearly as straightforward. So yeah, you can go through this chain of menus to turn it on, or you can pass a flag to the executable, to the console script. You can type. So what you want to do is pass. I'll do this in a moment, but you. What you want to do is pass. Oh, actually, I'll do this right now. This is the next thing coming up. So you'll want to do this in conjunction with a Python breakpoint. So everything stops and you can look at it. And okay, so I have my command, and I can pass JS debugger. We'll do a couple of things. Makes some sense. Where's my... Just a moment. Okay, that looks like that sorry, let me, I think I know why that's not working. Let me try with a different field. Oh, actually, here we go. There it is. Okay. So you'll get the scary. Oh, it was already turned on in my. There it is. Okay. Sorry about that. So this is what it looks like. It's like the dev tools are just popped out into their own top-level browser here. This thing just stops the execution of tests. So all the scripts need to be fully loaded in order to be debugged. So you have to let it. You have to actually interact with it in order to make things go. So you need to dismiss this alert, and it's going to. Yeah. So like I said, we do need to do this in conjunction with a Python debugger statement so that the world stops. Otherwise, it just runs. So this is the file we have. This is just really purely an exercise. What I've done is so in Python, this thing's called a decorator above a function, and it's basically a function that modifies the thing that it's decorating. And so this @property decorator just means that you can refer to this function without calling it. So it's purely a syntactic thing. So this lets us do self.back button as an expression as itself, and that will actually just run this code that's in the body here, right? We don't have to do this. We don't have to use parentheses. It's a syntactic convenience. And I guess it has some other uses as well, which is that's helpful for. It's a good way to make read-only properties. If you set something as a property this way, but don't define a setter also, then you can read it, but you can't. If you try to set it, that will be a static error. So that's or a dynamic error. So that's helpful. Cool. So what I've done is this is sort of a hypothetical UI library. It's just all of the elements in the URL in the navbar area from left to right. So the back button, forward button, the identity box, which is this little thing, and goes from there. And I have a little set of tests here that will set you on the right track. So these just make assertions about the elements as you've defined them. So self.back button will be available once you've filled it out, and if you've done this correctly, these assertions should pass. These should have these attributes. And yeah, so I just wanted to go through two of these as an exercise, or let's just start with one, see how far we get. So this is the URL bar drop markers. So this little guy, this little arrow, the down arrow there, is the target. So we'll try to find that. Okay, so I'm now in my Python debugger here, and I'm in the browser inspector here. So if you've used the DevTools before, this is probably somewhat familiar, but so these are our various functions, top-level functions up here. The debugger is useful if you're working on the JavaScript in the browser itself. We have a console, so we can evaluate. This is just a JavaScript read eval print loop. So you know, that's that sort of thing. And it's actually all of this is running in the scope of the outer Chrome window, right? So that's helpful. So we can do so our friend the URL bar, right? We can do document.getElement by ID, and we can give it URL bar, and that will actually return that element. And you can see it knows this is a UI element, so there's this red dotted line actually outlines the URL bar, which is that element. And then if we click this little guy, it opens up the Inspect tab and shows us the actual markup. And so this is just the tree of the actual markup of the browser UI. The first time I saw this, I thought it was completely magical. Let's look at this. So our target is this dot marker. So you can, if you click this, select this element here, everything you scroll over will get highlighted. But sometimes you just have to hunt for them yourself. So if we start from the URL bar, we know that that'll be a child. Okay, so this is what we want. Is this big enough for people to see slightly? Yeah.
It's very hard, your video.
Yeah. Okay.
Not sure if you can increase the font size.
Is that better?
A bit.
Bit? Okay. So the main idea is that this is the element we're targeting, and I can see everything of all of its markup in the inspector here, and so this is actually an anonymous node, which means it's using XBL, which is a sort of arcane Mozilla technology that's like, it's sort of it's like modularity for Zool markup. It helps scope things. So everything that's an anonymous node is called that because it's not visible to the entire tree. It's only visible to its direct parent. And so that's actually reflected in what we have to do to select the nodes. So if we did, if we tried to select this node by the usual means, we would not be able to find it because it's hidden from the tree. So what we have to do is we have to find its parent, and then we have to use a special kind of selector to get to that node itself. And so let's look at how to do that. And as you would expect, the parent is our URL bar element. It has the ID URL bar. So to do that, and this is so we need the parent. We know how to get that. Okay. And so in order to support this, all of our elements themselves support the find element function. And that will do a search in the scope of that node itself. So this thing has a method on it that's find element, right? And so to get to anonymous nodes, we have to use a different strategy than ID. We have to use a non-attribute. And this takes a dictionary as its second argument. that will be the attribute and the value we need to search for. And as far as I've been working with this, the best way to get a selector for these anonymous nodes is to use a non-ID attribute, which I think is pretty reliable. So what we want is the attribute, the non-ID, to have the value history drop marker. So
while Chris is typing one little note here, given that we run in localized builds, please never use a label or something else to identify an element, because this will clearly break in any other localized build. So ID, unknown ID, a class name, all this will work. So just take something which is not localized.
Right. I think that came up this morning too, with menus. Yeah, the IDs are good for that reason, and also if you have, so the thing that's difficult about finding a good selector is that the selector has to be unambiguous, right? You don't want the markup change to change the meaning of the test because you're using a certain selector. So anything that seems like an ID is going to be a good thing to go for, because that has, like, in the markup that has the semantics you want. You know, it's the identifier. It's the unique thing. Yeah, and so we found it. So let me do that again, because so this did a search from the URL bar to its child nodes, and it looked for one with this non-ID. And if I had made an error here, it would throw an exception. So this is an actual node we got, and I'm going to do see if I can click on it and just ensure and see that this is what I was expecting. Okay, I guess the click isn't opening that, but I'm fairly sure that's the correct URL. Okay. So yeah, that's the process that we're going through to make the UI libraries. So let's go back to Firefox for a second. So why do this, right? This is we're defining these selectors, but we have the tools available within the test. We have access to find element in the test that will, we could do this within the test themselves. The idea is that this is a layer of abstraction, right? So the good thing about having a member called URL bar drop marker is that I know what that means from the perspective of looking at the UI. And if the underlying markup changes, we only have to change it in one place, right? So multiple tests can use the URL bar drop marker and test its functionality. And if we hide the definition of the selector, the concrete selector in the library, then we only have to change that when the markup itself changes. So that's the basic plug for hiding these all in libraries. And you can see, if you look through the Puppeteer UI libraries, this is really a large part of what's happening in there. And I think, yeah. So, and then okay, the last thing I have is just a little bit of a rant about Marionette. Another thing that's really nice, so the thing that I think is really great about Marionette is that you can give in ChromeScope, you can give JavaScript to the browser and it will run it in ChromeScope. And from that, you really have the ability to do almost anything. And so when it comes to extending Marionette or writing libraries that you need to test with, you'll find that that functionality is almost certainly available from JavaScript. It's a last resort when it comes to usual testing tasks. But if you need to extend Marionette, it's fairly extensible. So that's really helpful. You know, almost everything that we do in our libraries is just a little bit of JavaScript that we've given to the browser to execute. The exception there is elements. That's another thing that Marionette gives us that we don't have natively, is this mapping of this reflection of elements in the client that are identified and then cached and then validated as the DOM is updated. Yeah. So that's it for. That's actually it. That's it for the formal presentation this afternoon. Does anybody have any questions, or would anybody like to see more stuff with the browser toolbox? That seemed a little quick, maybe.
I have a question. I was just experimenting while you were demonstrating the debugging thing, where you point to elements and you can see what the markup is for them.
Yep.
And I noticed that if I try to open the autocomplete results, and then I go back to the debugger, it closes. Is there anything that can be done about that, or are we just sort of stuck with that?
So I'm stuck with that. I don't know if Henrik has experienced it. Yeah.
So there is really no way. So whenever you move away the focus from the current window, any pop-up you have will close on them automatically. So that's a bit bad, but the only thing you can do here is to check the DOM, figure out what element you have to look for, and it's the way Chris has been shown here, which is way easier as what we have had to do with Mozmill before. Here you have an interactive debugger. You can do this all on the command line. With Mozmill, you would have to update the test, run the test, check if it works, update the test, run the test. So this is really crazy. So this is really a great way to at least get closer to this problem. But yeah, it's complicated.
And the good news also is that Mozmill has these definitions. So when you're doing if you're looking for a way to select something, you know, these selectors are in the Mozmill libraries, and so you can base what you're doing off of that and find an equivalent in the Marionette framework, and then do something like what I did this morning with making sure the URL bar pop-up opens, right? Just to ensure that you got the right thing from that version.
So there's one thing I have to add here. With the beginning of creating the Mozmill test, we were using lookup strings, which are a representation of the path from the top level elements of the Chrome or in content down to the elements you want to have, which can be normal IDs or selectors or unknown IDs. If you see such a combination, you can't use lookup strings, thankfully, in Marionette. This is really broken. Whenever developers are removing a scroll box or adding something else in the DOM, our tests are broken. So this is really crazy. So from now on, only use a selector by ID or by unknown ID and go from top to down. So with this, we can make sure we don't break if developers are simply changing the style and add another div or whatever else. So this makes our test way more stable. So if you see lookup strings, simply convert those to unknown ID find element calls.
Right, and if you are using an ID and it gets updated, it's just a matter of updating the ID. Well, you don't have to depend on the whole structure to get to the new.
We did a lot of work in our Mozmill test to get rid of those lookup strings, but I think there are still a couple of modules where those are present. And now that we work on Marionette, there's no reason to exchange those anymore in Mozmill. So simply ask if you have questions.
I do actually. I was also experimenting with something earlier that could. I mean, I think it would be a bit of a hassle to work with, but that you could potentially use if you were trying to find something where the box disappears, like I was talking about. Is I noticed that if you set the context to Chrome, then you can print self.marionette.pageSource, and it will output the entire DOM for you. And I wonder if you call that immediately after opening that dropdown, if it will see all that stuff and show it to you. I'm guessing it probably will, but of course, as I saw, it's a lot of stuff to look through to try to find what you're looking for.
So usually when you have those pop-ups, the pop-up elements will always be present in the DOM. They are simply hidden. If you have context menus, you can always find them via the inspector. They are not under the element. They are under the top element, I think directly under the root element, which is window in this case. There's a subcategory for context menus also. So all those are listed there, and it makes it easier to figure out the ID of those elements. But it's not always the case. For the notification bars, which you see when you install an add-on, and which appear below the tab bar or the bookmarks toolbar, those are dynamically created. So this is really hard to get details. We don't have those yet in our libraries. I think I'm sure if you hit it, Bob, but someone did. So that's really something we will have to add to make sure that we can wait for the specific notification bar to appear.
Yeah, and if you get desperate, you can do things like find IDs in the inspector and then go to DXR and find where they are in XML files and look at the markup directly, like I've done here.
So the Gaia one that we were using, XML, we got a lot of pacing stuff, which was kind of hard for some of the is that the case for what we needed to or expected need to do in Gecko for desktop to also be heavily pacing? Or does it just depend? Like, I think we were doing network functions.
Oh.
Gaia specifically.
Yeah, it's so the Mozmill libraries are primarily synchronous. Like when you call into a Mozmill library, the useful things that sorry, the question was from Stephen. He was saying that there's the experience of working with Gaia tests that there's a lot of need to execute scripts that have asynchronous effects, and that was sort of a hurdle for writing tests that are test certain things. So I think it's a goal of the Mozmill libraries to be synchronous. So we are working on a library, or Henrik is working on a library to register and report observer notifications, and then also one for events in the Chrome DOM. And so between that and the Wait library, I wouldn't expect that we have to do that. The tests we're writing have to do a lot of things with lots of scripts that have asynchronous effects. I would not expect that. Yeah. Are you using execute async scripts?
Oh, I'm not. It's just a general question.
Oh, okay.
Yeah.
All right. Yeah. The answer is that we hope to hide that sort of thing in libraries for the most part, which should be possible. Okay. I think that's a wrap for this portion. Like I said, I'll be online for the rest of the day and certainly tomorrow. I think. Do you guys want to? Are you guys going to be in the office tomorrow? Okay, on video.
I think Mark is planning to go back to town.
Do you? Okay.
I might be okay.
All right. Well, I'll come in here in the morning and see if people are hanging out, and come back into the video room. We can check in Yeah, so if everybody wants to come back to my video room tomorrow morning, I'll drop a note in Pound Automation when I'm getting cranked up, and we'll talk to you then.
I've only been going for 4 years.
Yeah, we have and then usually ends around 9:45. Sometimes it goes a little longer by 10.
Okay, I'll stop the recording.